Hey everyone, Mr. B here. Give me a shout in the chat if you can hear me. I've never streamed before, so this is new for me. Can anyone hear me? Anyone there? All right. Awesome. So thanks so much for joining me. I'm Mr. B. I teach at a school in Ohio. Give me an indication of where you're joining from. I'm curious if other people from other schools are watching. All right, so here's my plan. It's 4 p.m. Eastern. I want to speed run through hundreds of problems. I'm going to balance A, B, and BC calculus. Currently, I have a test maybe that you saw on AP Classroom. It's the 2019 test. But I have some other tests that I want to go through as well. And I thought I'd start with AB calculus, and we'll run through a full test. Or I'm sorry, I'm going to start with BC, and then we'll go to AB. And I'm just going to go through the test and talk through it. And we'll see how many I can solve. Are you ready? Okay, so non-calc first, BC, here we go. So when you integrate, you have to find an antiderivative. And remember, by the power rule, you bump up the power by 1 and divide by that new power. So in problem 1, that would give us x to the 4th. And when you integrate x, you get x squared over 2. And we now just have to evaluate that from 1 to 2. So remember, you plug in the upper bound first. 2 to the 4th is 16. 2 squared, but over 2 would be 2. And when we plug in 1, we get 1 minus a half. So we have 14 minus 1/2, which is 28 halves minus 1/2. So we should have 27 halves, which is A. Let's see how we did. Yep, crushed it. In 2, we are given a function, and we want to find the value of x where there's a local min. So just be on the lookout that we're after the x value, not the actual minimum value of the function. So we take the derivative. We get 3x squared minus 6x minus 9. We factor out a 3. Remember, critical values are where the derivative could be 0 or undefined. So we want to factor this. And it can't be undefined. So where is it 0? That's at 3 or -1. So we'll make a simple sign chart. I like to write f prime and f. So let's test a value to the left of -1, say -2. 3 is positive, -2 minus 3 is negative, and -2 plus 1 is also negative. So we'd have positive there. Since all the multiplicities are 1, we just know this will alternate in sign. So that means f goes up, then goes down, then goes up again. So where is there a local min? That's where f decreases and increases. So that should be at x equals 3, which is A. How'd we do? Got it. Problem 3 is a derivative question. So this is us testing the chain rule, right? So just look at the layers of how this is nested. We have a 2. The power rule brings down that 2 of sine squared, and now the power is 1. So you could write to the 1 if you wanted. The derivative of sine is cosine, still of root x. And now we have to take the derivative of root x, which you should memorize as 1 over 2 root x. So let's see. One of these 2's would cancel. So we should get something like 2 sine root x, cosine root x, all over root x. That to me looks like option D. 3 for 3. Question 4, we're given x of t and y of t. What is the velocity vector at time equals 1? So to find the velocity, whether you're in AB or BC calculus, we need to find the derivative of position. Here we have 2 components, the x and y components. So we'll derive them both, and we have to do this by hand. We don't have a calculator. So the derivative of x would be 2t over t squared plus 1, right? 2t is a result of the chain rule. We might as well plug in 1, which would be 2 over 2, which is 1. Now we take the derivative of y. That would be negative e to the 3 minus t, the negative due to the chain rule. When we plug in 1, we get negative e squared. So our velocity vector should be 1 negative e squared, which looks like option B. Not so bad. Okay, I need my glasses. E to the n over pi to the n. What I like to do with the series is plug in a few values just to get a sense of what the series is. So if we plug in 1, we'll get e over pi. When we plug in 2, we get e squared over pi squared. Plug in 3, e cubed over pi cubed. I see this as geometric with a ratio of e over pi. So remember, the sum of an infinite geometric series is a over 1 minus r, as long as the absolute value of r is less than 1, which it is. E is smaller than pi. So we plug in our first term, which is a, that's e over pi, over 1 minus our ratio, which also happens to be e over pi. Multiply each term by pi just to clear those denominators, and you get e over pi minus e. So that should be the sum, which is, I think, option B, if my eyesight is correct. Yep. So just a over 1 minus r, that's what you need for a geometric series. 6, oh no, I thought this would happen. Yeah, my formatting is off, but we'll do our best. The function h is given by that, which I think says f prime over g. And we're after h prime, so we need to take the derivative. We'll use the quotient rule. So we take the derivative of the derivative with g left alone. Then we take the derivative of the denominator with the numerator left alone, all over the denominator squared. So now I have to use this annoying table. Sorry, that's h prime of x, not h prime of 2. So now let's plug in 2. I need f double prime of 2, which I luckily can read as 3. G of 2, yeah, how am I going to do this? Oh, that's not so bad. G of 2 is negative 2. G prime of 2 is 5. I'm just reading off the table. F prime of 2 is negative 3. And G all squared, well, negative 2 squared is 4. So I have negative 6 plus 15 over 4, which is 9/4. Hopefully my arithmetic is right. I'm going with option A. Yep. How are we doing? Is this fun? Is this not helpful? I don't know. Okay, Maclaurin series. Someone wanted to see that in the chat. So you need to know some parent series. E to the x, sine x, cosine x for sure. So cosine x, recall, is the even powers and their according factorials, and it alternates. So you would have 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. So it alternates just with the even ones. We want cosine of x squared, though. So we plug in x squared, where x is. So now we'd have x to the 4th, x to the 8th, right? Because x squared to the 4th is to the 8th. On and on. And now we just need to multiply by x. So each power bumps up by 1. Hopefully that's enough terms to know what choice it is. X minus x to the 5th over 2 factorial. Well, it's got to be option A. All right, question 8. A limit. Okay, we know the answer is immediately 0. E to the x grows a lot faster than any polynomial. Sorry, that's pretty small on your screen. But we have x squared versus e to the x. As x pushes to infinity, e to the x grows faster, so it should be B, 0. So I'll just write B, I guess. There's no work to show there. f is not differentiable at x equals 5. Which of the following statements must be true? So be sure that you read that must be. Just because it's not differentiable, it could be continuous, right? You could have like an absolute value function, which is certainly continuous. So A is wrong. The limit does not exist. Well, my graph still shows that the limit could exist. C is the statement that must be true because this is just the definition of a derivative, right? The limit definition is exactly what's expressed in C. So saying not differentiable and saying that limit doesn't exist are the same thing. C is it. You should know both limit definitions, the f of b minus f of a over b minus a1, and the f of x plus h minus f of x all over h1. Two different definitions. We're on to 9. The second derivative is this. At which of the following does f have a point of inflection? Okay, careful. A point of inflection isn't just where f double prime is 0 or undefined, but you have to show there's a sign change of f double prime at that specific value. So first, what are our special values? Looking at the factorization they already gave us, f double prime is 0 at 0, 3, or 10. But where would a sign change happen? Well, at x equals 0, a sign change would happen because if I plug in a negative value or a positive value, that x could change sign. At 3, a sign change could happen because it's to the 5th power, an odd multiplicity. But around 10, a sign change would not happen, right, since it's squared. So there'd only be 2 points of inflection at 0 and 3, which is option B. Yep. We're 11 for 11. Or wait, was that 10? I'm off somehow, but now we're on to 11. An integral, okay, immediately you can see u sub's going to work because the derivative of e to the x minus x is e to the x minus 1, and that's what we need to cancel in the numerator. What about the bounds, though? Remember, the bounds should change if you're changing in a definite integral. So if x is 0, we'd have e to the 0 minus 0, which would become 1. And if x is pi, we'd have this annoying bound e to the pi minus pi. So those are our new bounds. I just plugged in 0 and pi in for x to get what the new u bounds are. We already said e to the x minus 1 will cancel. We have 1 over u du. That's simply natural log of u. We plug in the upper bound. We plug in the lower bound. Of course, natural log of 1 is 0. So we'd have option D. Sweet. In which of the following intervals must there be a c such that f prime of c equals 2? Let's see if we can look at the full table. So we're told it's a differentiable function. That's really important. Since the function's differentiable, it's also continuous. So we can use something called the mean value theorem. We're trying to find an interval where the average rate of change is 2. Because if the average rate of change is 2, the instantaneous rate of change must be 2 somewhere on that interval. So let's look from 0 to 4. Is the average rate of change there 2? No, it would actually be negative 8 over 4, which is negative 2. So that's out. On the interval 4 to 8, we'd have a change of 2 for y and 4 for x. So that would be 2/4 or 1/2, not the rate of change of 2 that we want. So that's up. From 8 to 12, we'd have a change of 8 over 4. So that's what we want. It should be option C. So mean value theorem for the win. 13, we have a differentiable function. Euler's method, what I like to do is set up x, y, the slope, and our tangent line. Simple table. A, B will be after this, so hold your horses. We're told that 0 and 2 were our initial point. We use the differential equation to find the slope. So if we plug in 0 for x and 2 for y, we get an initial slope of 4. So we can write 4x plus 2 for our tangent line. Now, where are we trying to get? we're trying to get to negative 0.4 for our x, but we have 2 steps. So we have to go to negative 0.2 and then negative 0.4. So how do we find the y for that x? Well, just plug in x to our tangent line. 4 times negative 0.2 is negative 0.8, plus 2 is 1.2. So now we do this all over again, plug in that x and that y to find the slope. Negative 0.2 plus 2.4 would be 2.2. So 2.2x plus 0.2 plus 1.2, sorry, it's small, should be our new tangent line. And now we plug in negative 0.4. Negative 0.4 plus 0.2 is negative 0.2. 2.2 times negative 0.2 is negative 0.44 plus 1.2 would be 0.76. So I'm going with A. Yep. So just make a table. Euler's method's really easy. You're just using a tangent line over and over. 14. We're about halfway through the non-calc. What's the slope for that at that point? So we just take the derivative. That's 1 over 2 root x plus 1 over 2 root y. Don't forget dy dx since we're deriving y as a function of x. And the derivative of 2 is 0. I like to plug in the point right now. So if we plug in 9/4, the square root of 9/4 is 3/2. And 3/2 times 2 is 3. If I plug in 1/4 for y, the square root of 1/4 is a half. 2 times a half is 1 times dy dx. So dy dx should be negative 1/3, which is option B. Yep. So that's just testing implicit differentiation, easy stuff if you're taking BC. We have an improper integral, so I'm going to disguise it to be a limit. So this is easy power rule stuff, right? So we bump up the power by 1. That would be negative 1/2. Then we need to multiply by negative 2 to fix that power. So that would be negative 12. And then we have from 1 to b. We plug in b. So that's negative 12 over root b plus 3, if you want to write it that way, plus 12 over root 1 plus 3. As b goes to infinity, this will go to 0 since b is in the denominator, and 12 over 2 is 6. It should be C. Hey, we're halfway done. If dy dx is 2 minus y, and if y equals 1 when x equals 1, then y equals. One way to solve this is just test the choices, take the derivative of each choice, see if dy dx is correct, and also check that the initial condition is correct. I'll solve it in the more traditional fashion, though. This is a separable differential equation. So we can get all the y's together, all the x's together. Let's integrate. So we get a natural log, but don't forget to fix the chain rule, right? You need a negative because the derivative of the inside is negative 1. When we integrate the dx side, we get x plus a constant. So now let's use the initial condition. When you plug in 1 for y, you get the natural log of 1 on the left side, which is 0, and 1 for x, so c is negative 1. So now we have this. Multiply both sides by negative 1. Exponentiate. Move terms around, you get something like this. Now let's just check, when we plug in 1, do we get out 1? Well, e to the 0 is 1 and 2 minus 1 is 1. So yes, the initial condition still works. And this looks like option B, which is correct. We're set 16 for 16, folks. Isn't that pretty cool? Which of the following series converges? Okay, so they're all alternating. Remember, the alternating series test requires 3 conditions. Does it alternate? Does the non-alternating part go to 0? And does it decrease? Well, they all alternate. Notice option A won't go to 0. 1 minus n over n would go to -1, so that one's out. N plus 1 over 2n would go to a half, not 0, so that one's out. N squared over 3 root n, well, there's more n up in the exponent in the numerator than the denominator, so that would go to infinity. That's out. It's got to be option D, which alternates 2 root n over n does go to 0, since that's 2 over root n. And 2 over n, root n would decrease. So I'm going with D. '18. Okay, a polar problem. Someone was asking about that before the live stream started. Let R be this region in the first and second quadrants between the graphs of 3 plus 3 cosine theta and 4 plus 2 cosine theta. So the first thing I want to figure out is which. Notice the 3 plus 3 cosine theta is the innermost curve. The way I can figure that out is when theta is pi. Wait, let me think about this. Yeah, when theta is pi, you would get 3 minus 3, which is 0. So let me do my best to draw this. We have this curve and a curve like that. This one is f of theta, and the outermost one is g of theta. So when we find a polar region, we need 1/2 integral from one bound to the next. That would be 0 and pi. And then our radius squared. Well, we have 2 radii. G of theta is the outermost radius, and f of theta is the innermost. So we would need to square g of theta and separately subtract f of theta. It's outer squared minus inner squared. So yeah, all of these are nonsense besides option D. So just remember 1/2 radius squared, but we have 2 radii, one squared minus the other. How are we doing in the chat? I'm not really paying attention. I need a moderator, I guess. Which of the following statements about the series is true? Well, it alternates. What are the choices? Let's see. Compare it to 1 over n. Comparison. Notice option D is compelling, right? Alternating series test. Let's go through the alternating series test again, and hopefully that works. And then we'll say D. So what do we need to use AST? Does the series alternate? Yes. Will n over n squared plus 1 go to 0 as n goes to infinity? Yes. Does n over n squared plus 1 decrease? And it doesn't have to decrease all the time. It's just eventually decreasing. Well, sure, right? The denominator is growing much bigger than the numerator. So term after term, that'll go to 0. I'm going to go with option D. You can never use AST to show that it diverges, but we're good with that. Which of the following cannot be determined? Interesting. So we're told the same interval, 1 to 4 for both. So of course we can figure out option A, right? If we switch the bounds from 4 to 1, we already know the integral for g from 1 to 4, so that can be determined. We, of course, can multiply by 3. That can be determined. We could do any linear combination like option D is showing, but we can't find the product of f and g. So that's option C. Something like that would need biparts. '21. Interval of convergence. Okay, so one way that you can hack this is notice -4 is the center, right? If -4 has to be the center, B can't be right, because that's saying 0 is the center. C can't be right, because that's making, what, 5 be the center or something. A is compelling because that's -4 at the center and a radius of 5. We just have to test the endpoints. Or D could be compelling, saying the radius could just be infinity. So how are we going to know which it is? We could use the ratio test. Bump up each n by 1. Then multiply by the reciprocal. So what can we simplify? Well, we have one more x plus 4 upstairs, so we have x plus 4. We have one more 5 in the denominator. And notice n over n plus 1, while they don't algebraically cancel, that goes to 1 in the limit. So we get x plus 4 over 5. And by the ratio test, you know that needs to be less than 1. So the absolute value of x plus 4 has to be less than 5. And sure enough, it is not an infinite radius of convergence. I'm not going to bother testing the endpoints. If we go 5 away that way or 5 away that way, we know we have to be from -9 to 1. So A is the only option that makes sense. It's not worth your time testing those endpoints of -9 and 1. We're 21 for 21. What is the slope of the tangent line for that at that? Remember, x is r cosine theta, r being 3 theta. So let's take the derivative. By the product rule, 3 theta's derivative is 3. And cosine theta's derivative is negative sine theta. Let's plug in pi over 2. Every cosine disappears and every sine is 1. So we get -3 pi over 2. Hold on to that and we'll do the same for y. Y is r sine theta, r being 3 theta. The derivative of 3 theta is 3. The derivative of sine is cosine. Plug in pi over 2. So we get 3 for that because cosine disappears. And then how do we get the slope of the tangent line? Well, that's just dy dx, which is dy d theta over dx d theta. The 3's cancel. We should get -2 over pi, which is option B. Did I make an arithmetic error? I did not. Nice. On to 23. The definite interval blah is a left, right, trapezoidal sum. Which inequality is true? Okay, so root x is an increasing but concave down function. So if we draw a left Riemann sum, notice every rectangle will be underneath where it needs to be. So I'm going to say the left is going to be the lowest. The right's going to be the most, because when I draw a right rectangle, well, let me start over. When I draw a right rectangle, that peaks over the curve every time. So the right's going to be the biggest. And when I connect the dots to make a trapezoid, that's going to be bigger than the left one, but smaller than the right one. So it should be, what did I say? Left, then trapezoid, then right. So that's, oh, interesting. Left trapezoid, right, A and B are both those options. Notice the actual area will be above the trapezoid, but less than the right sum. Do you see that? That trapezoid is a little underneath in the actual area when I fill it in. So the actual area will be squeezed in there, which is, of course, the integral. So that should be option B. Yep. Just draw a simple picture. I wasn't expecting to ace all these. I'm sure I'm going to mess up somewhere. What is the value of that? This is really interesting and simple. When you integrate f prime, you're back to f. Plug in 12, plug in 0. F of 12 looks like -4. F of 0 is 4. We should get -8, which is A. Grand. So when you integrate f prime, you're back to f. This requires the integration by parts. So let's let u be x, du is dx, dv is everything left in the integral, and integrating gets us back to f. So how does integration by parts work? You multiply u and v together and subtract the integral of v du. We have bounds here, right? From 0 to 2. If we plug 2 in, we get 2f of 2 minus 0 f of 0. So that doesn't matter. Minus this integral, which I think they tell us the value of. So f of 2 is 5. We get 10. The integral is 7. 10 minus 7 should be 3a. Next. Which series is conditionally convergent? So conditionally convergent means when we take the absolute value of the terms, that does not converge, but the series itself does converge. In 1, when we take the absolute value of the terms, we get 1 over n factorial, which converges really fast. You can see that with the ratio test. So that will be absolutely convergent. 1 only, or anything involving 1 is out, because that's absolutely convergent. 2 is a classic example of conditional convergence, because if I take the absolute value, I get 1 over root n, which by a p series has p equals 1/2, which will not converge. But the series on the face of it does converge because of the alternating series test. So 2 is a classic example of conditional convergence. And look at that. I didn't even have to check 2 from the choices. 3 is that conditionally convergent as well. Well, when we take the absolute value of the terms, we get this, which will diverge. It's just like a harmonic series. But the series itself does converge, again, by AST. So 2 and 3 work. That should be C. Yep. We're almost done with the multiple choice, at least the non-calc. 27, I'm going to sketch a curve or a graph. The square root function looks like that. The x-axis and x equals 10. So there's our region, which gives the volume when around the y-axis. Okay, so we're going to have an outer radius and an inner radius. The outer radius is 10, so I should see 10 squared or 100. So it can't be these. And the inner radius is whatever it is to the curve, but careful, we need to solve for x. If y is root x minus 1, then y squared plus 1 is x. So I should see that squared. Well, it can't be b, right? Because they're using x. So that would be silly to choose. It's got to be d. 27 for 27. We're on to 28. Okay, so to know the second derivative, we take the derivative of dy dx over dx dt. That's a formula you should know. Wait, the stream isn't working? What disappeared here? So we need dy dx first. Dy dx is dy dt over dx dt. Now we need the derivative of that with respect to t. Well, that's just 1/5 cosine t squared times 2t. We now take that divided by dx dt. So the second derivative would be 1/5 cosine t squared times 2t, what I found, divided by dx dt, which was 5. So we should have over 25 in our answer. That's option C, because we're dividing by 5 and then dividing by 5 again. $29. Maybe. It's resisting. Which of the following expressions is that? All right, so this is testing your idea of a Riemann sum. Oh, sure, I can say if it's BC, if that's helpful. This is definitely an AB or BC problem. Both are worthwhile. Which of the following definite integrals is representing this limit? So notice we have a 2 plus, 1 over n, 2 over n, 3 over n, and so on. What that 1 over n represents is b minus a over n, which is our change in x. So that tells me a and b should be 1 apart. That can't be c then, because 0 and 2 are 2 apart. And I always have a choice. That 2 plus I could have be part of the function, or I could start at 2, but not have that 2 be part of the function. And here's what I mean. If I start at 2 and go to 3, then I would just be integrating 1 over x. If I start at 0 and go to 1, again, 1 apart, then I'd have to have 2 plus be part of the function. Notice only one of these is an option. Option D goes from 2 to 3, but that should just be 1 over x. We've like over accounted for that 2 plus 1 too many times. It's got to be option B. So just think, is that 2 part of a bound or is it part of the function? This one is a BC question. A Maclaurin series is given by that, and it converges to f of x. G of x is e to the f of x. What is the x squared coefficient? Okay, so this must be the hardest one on the non-calc if it's the last one. Remember, e to the x is, well, we could do this one of 2 ways, but e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial, blah, blah, blah. I think I'm going to do this a different way. I'm not going to use the e to the x parent series. So we want a Maclaurin series, right? That means plug in 0. Then we need the derivative, and we'll plug in 0. And then we need the second derivative, and we'll plug in 0. So what is f of 0? Well, we're given that function, and f of 0 must be 2. So e squared is our first term. Now let's take the derivative. That would be e to the f of x times f prime of x. If we plug in 0, we get that. E to the f of 0, well, we already know f of 0 is e squared. And f prime of 0 must be the coefficient of x, which is 3. So there's g prime of 0. G double prime, we need one more derivative, so we could derive g prime. So we get e to the f of x times f prime squared plus e to the f of x times f double prime. In retrospect, since I just wanted the x squared coefficient, I didn't need to do g of 0 and g prime of 0, but we need to take a derivative to get to the second derivative anyways, right? So we worked our way up to g double prime. Let's plug in 0. Okay, here we got to be careful. F of 0 we know is 2. F prime of 0 we know is 3, and 3 squared is 9. That's 2 again. What's f double prime of 0? Remember, the coefficient of x squared is f double prime of 0 over 2 factorial. So that means f double prime of 0 has to be 2, since 2 over 2 leaves a coefficient of 1. So again, f double prime of 0 must be 2, because 2 over 2 is 1, which is the coefficient of x squared in the function f. Put all together is 11 e squared. So now, how do we find the x squared coefficient of g? It's g double prime of 0 over 2 factorial x squared, which is 11 e squared over 2 x squared. That's our coefficient, which should be d. Did I get 30 out of 30? Let's hope. Yay. I aced the non-calc. Okay, so good recommendation in the chat. In the future, I will make it clear if this is a BC only problem or a B. But yeah, there is the non-calc portion. Let's now move to the calculator. And then I'll do an A-B test next time. Okay, so we're doing the 2019 calculator portion of the 2019 BC calculator multiple choice. So we're given a graph of f prime. Where does f increase? Well, f is increasing when f prime is positive. And f prime is positive from 0 to 2 or 4 to 5. So that should be option D, which is down there. Yep. Oh, and that's definitely an A, B, or BC question. 2, we're told a derivative. already we see we have to use the calculator. I'll do my best to manage that. How much does y change as t changes from 1 to 6? Okay, so there's a few ways we could do this. If we integrate dy dt, and this, by the way, is AB or BC, if we integrate, that gets us back to y. And by integrating from 1 to 6, that tells us the net change. So all we need to do is integrate this function, blah, blah, blah. And that will be our answer. So now I need to figure out how to get the calculator to appear. And sadly, that needs to go away for me to be able to click calculator. So I'll do my best navigating this. So all we do need to do is integrate. Remember, we type int on Desmos from 1 to 6, I think it was. And then I have to type this in, which is 6 e to the negative 0.08 t, or I could type x, it doesn't matter, minus 5 squared. And then dx. So the net amount of change is option D. So integrating dy dt gets you back to y, and by plugging in 1 and 6, that tells us how much y has changed. No, I'm good. Question 3, definitely not needing a calculator. The function, this is an A, B, or BC question. The function has the property that the limit when x approaches 1 from the left is going to infinity. So 1 to the left is going to negative infinity in option A. B is a contender, C is a contender, D makes no sense. 1 from the right is negative infinity. Well, yeah, those are still compelling choices. When x gets super negative, we should have a horizontal asymptote at 2. So that's wrong. It's got to be C. Tara's heart rate during a workout is modeled by this differentiable function, where h is measured in beats per minute, t measured in minutes. Which of the following gives Tara's average heart rate? A, B, and BC question, both are fine. The average should jump out at you. This is an average value question. So to find the average value, we just integrate the function over the bounds, but remember to multiply by 1 over b minus a, since that would be 1 over 30. From 30 to 60, that's option B. Taylor series problem is definitely a BC only topic. We're told f, f prime, f double prime, and f triple prime, and we're asked to find a third degree polynomial, a Taylor polynomial, and then plug in a value. So I'll just type it into the calculator. To find a third degree Taylor polynomial, we just build it up term by term. So we need the function value, which is -1. We then need the derivative, which is 4, times x minus our center. Now be on the lookout. We need the second derivative, but divided by 2 factorial, x minus the center squared. And they want a third degree, so we have to do one more. We need the fourth derivative, which is 12, but over 3 factorial, which is 6, and then x minus 2 cubed. So we took the appropriate derivative with our center plugged in, divided by that factorial, so over 3 factorial in this case, x minus 2 to that appropriate power. I should have labeled this f of x. Can I get over here and call it that? Or maybe I call it g of x. Let's give it a name, and then I can just put 2.1 in, and we're done. So don't forget to divide by those appropriate factorials. It should be negative. Is that option B? It's sort of rendered weird. Yeah. On to question 6. We're given the derivative and the length of the graph. Okay, so this is a BC problem as well. To find the arc length, there's a few ways you should know for the BC exam. using a function of x, the arc length is found as the integral. From start to end. This is annoying, right? Of how it like makes it hard to read. I guess I would guess it says 1.5. And then the arc length is the square root of 1 plus our derivative squared. So that's a formula to know. But the derivative, they tell us, right? And when we square that square root, we just get x cubed plus 1. So I'm just going to get rid of this squaring. So I'd have 1 plus, when I square that square root, it's x cubed plus 1. 2.497, that looks like option B. Yep. So remember, integral square root 1 plus f prime squared. We're asked to find the appropriate slope field. H is a continuous function, which could be the slope field for the dy dx equals that. Let me look at the choices. This one's interesting. H is a continuous function of x, which could be the slope field for dy dx equals that. I'm not seeing what they're asking us to do. If the function's continuous, then that means the slope could never be undefined, right? So C is clearly out, because there I'm going vertical. But how are we to determine which one's the slope field if we don't know what h of x is? Yeah, this one I'm uncertain about. Any ideas in the chat? Airball, yes. I feel like I'm missing something. I'll come back to that one, I suppose, because I'm not seeing how knowing a continuous function alone helps us pick the slope field. All right, well, I'm not perfect. Okay, this one's easy. This is definitely an A-B question. For what value of k, if any, is f continuous? We just need the function value to be the same for both pieces when x is 3. So I'll just go straight to the calculator. If things could move out of the way for me. Good enough. So let's plug in 3. I need k cubed. We're plugging in 3 for x to be the same thing as 16 over k cubed, or k squared, that says, minus 3 for x. And the question is, what value of k will do the job? Let's us see. So right now I can see I'm getting out 4 and negative 8, I think that says. If I plug in 2.081, I get 12 something and 12 something. So I would go with option A. Yep. So use the calculator however you want. You just want the left and right limits to be the same when x approaches 3. So we tested the first value of k worked. Here's a function that's differentiable. Well, let f be a differentiable function. The figure above shows the graph of the line tangent to the graph at x equals 0. So we don't know the graph of f. I don't know what rigatone is telling me. Let f be a differentiable function. We're told the tangent line. Which of the following must be true? So notice the tangent line and the function value would be the same when x is 0. And we're told that that's negative 2. And also the slope of the tangent line and the derivative are the same when x is 0. If we count the slope, it goes 2 down and 1 over. So the slope of the tangent line is negative 2. So I know f prime of 0 is negative 2. And I know f of 0 is -2. They're the same. So that's option C. So whoops, I didn't mean to click that. So again, from the tangent line, we know f of 0 and f prime of 0. So they both happen to be -2. A referee moves along a path. The velocity is given by blah. What is the total distance traveled? Okay, the total distance traveled, this is an AB question, or BC. The total distance is just the integral of the absolute value of the velocity. So we want to go from 2 to 6. So we'll integrate. Sorry, I'm not used to using an iPad to type. And then our velocity function, 4, I could type x, it doesn't matter. And then cosine 2x plus 5 dx. 21 something. That's option C. Be careful. If you don't include absolute value, then you're finding the displacement, not the total distance. Here's a graph of f, and we have an integral defined function. We're integrating that f from 0 to x. Where do we have an absolute maximum? So especially on the free response, you want to test, and this is an A, B, or BC question. You want to be sure you test the endpoints and any critical values. So what are the endpoints? They are -4 and 3. And what are the critical values? That's where the derivative of h could be 0, which is f. Where is f0? At -2 and 0. So we now need to plug in -4, -2, 0, and the endpoint 3 into this h of x function. And that will help us figure out what the h values are, and then we'll just pick the biggest. So at 0, it's easy, right? The integral from 0 to 0 is 0. So maybe I want to bring up my notepad so I can write here. One second. Okay, so h of 0 is 0. H of 3 is the area under the curve from 0 to 3, which is this shape together with this trapezoid. So the triangle is a 2 by 2 triangle, so that area is 2 but negative. And the trapezoid, you could even count it, has an area of 1.5 but negative. So h of 3 would accumulate that area, which of course isn't going to be bigger than 0 if we want to max. So 3 can't work. We said we need h at -2 as well, which is the integral from 0 to -2 of f of t. We can switch the order. So what is that area? It's 2 wide and 1 tall. 2 times 1 times a half is 1. So that area would be -1. So 0 is still bigger than what occurred at -2. So that's out. It comes down to -4. So we could switch the order of the bounds and go from -4 to 0. From -4 to 0, we have a 2 by 2 triangle, which has an area of 2 but negative. And then we add on the area of 1 that we just found. So that would be an area of 1. And 1 is bigger than 0, so it occurs at the endpoint of -4. So it should be A. Yep. So please, absolute maxes and mins, you have to test the endpoints and the critical values. That's a function of the extreme value theorem. And that idea of those important values to test is called the candidates test. So the candidates were -4, -2, 0, and 3. We're told a position. This would be a BC only topic. Ethan, yes, you need to know the extreme value theorem. That just says if a function is continuous on a closed interval, you have to have an absolute max and an absolute min, which could occur at the endpoints or the critical values. So we're told a position with x and y. That's a BC only topic. What is the speed? The speed is defined as the square root of x prime squared plus y prime squared. And I am not going to do any derivative calculus by hand. If it will let me pull up the calculator. I'm going to avoid hard work. I'm going to define f of x to be the x of t function. I'm not even going to type in t. I'll type in x. So that's e to the negative x. And I'm going to define g of x to be the other function, which is sine of 4x. I'm using x in place of t. All right. And this is good practice, especially on a free response. You should know how to use the calculator to avoid hard work. Never take derivatives or integrals by hand. The speed is defined to be the square root of f prime squared, which is the x component squared. Come on. There we go. And then squared plus, this is a lot easier to type on a computer, g prime squared. That's the speed for any x. The x we wanted was, I think that says 1.2. So I'll just put 1.2 in for x, and we get 0.46 or so. That's option C. Yep. So just think Pythagorean theorem when you calculate speed, but with x prime and y prime. 13, this is an AB topic. For how many values of x in that interval is the derivative of f equal to the average rate of change of f? So you're going to have to painstakingly watch me type this f of x in. F of x is x to the 4th over 4 minus 2x cubed over 3 plus x squared over 2 minus x over 2. Okay, so now that we've typed all that, let's graph the average rate of change, which is f at 1.565 minus f at 0, all divided by the change in x, 1.565 minus 0. So that blue horizontal line represents the average rate of change that we want to get out. We want to see when that is f prime. So I'll graph f prime on its own line. Okay, I don't need the red graph anymore. The question is, how many times does the derivative intersect the average rate of change? But careful, we're only wanting to go up to 1.565. So there's a qualifying one, there's another one, and I think there's 3, right? There are 3 places on that interval where the average rate of change is the derivative, f prime. So I'm going to go with 3, which is C. Yep. So yeah, use the calculator at your advantage. I defined f of x. I graphed the average rate of change as that target value in f prime, and we saw 3 intersections. Just be sure you're on the interval that they asked. Okay, this is definitely well, it could be AB or BC, I guess. If you take BC calculus, you might recognize this as something called a logistic function. But even if you haven't taken BC Calc, you should be able to interpret how to model this. It says the population P of rabbits on an island grows at a rate that is jointly proportional to the size of the rabbits and the difference between the rabbit population and the carrying capacity. The carrying capacity is 2,400. So I know that in my differential equation, I should see P twice because it's jointly proportional to that population P and the difference between 2,400 and P. So that's going to be option D, right? Proportional just means K times, and we have P and then 2400 minus P. This you should know if you're in BC Calc is called a logistic differential equation. But even if you don't know the name, you should be able to translate words to symbols. 14, a region is bounded by two concentric circles as shown. The radius of the outer circle R is increasing at a constant rate of 2 inches per second. So we're told dr dt. The radius of the inner circle R is decreasing at a constant rate. So that's -1 inch per second for d little r dt. I probably want to pull up my notepad here. This is really annoying to try to fit all into one page. That's not bad. So what did we say? We're told dr dt is 2 and little r dt is -1. What is the average rate of change in square inches per second of the area of the region when big R is 4 and little r is 3? Well, let's write an expression for that area. This is definitely AB or BC, right? It's a related rates problem. The area that's trapped between there is the big area minus the little area. Let's derive with respect to t. We get 2 pi r dr dt, don't forget the chain rule, minus 2 pi little r dr dt. So what's the instant that we're interested in? When big R is 4, d big R dt is 2. When little r is 3, and d little r dt is -1, right? We had a decreasing rate. That's 16 pi plus 6 pi. So we should have 22 pi. Cool. So yeah, I've aced all but one of the calc, but I'm still sort of stuck on this one. So let me read it one more time. H is a continuous function of x. Oh, right. H of x. Sorry, my brain is not braining, as we say. H only depends on x, right? So the slope should only depend on x. So notice option B, for a given x, the slope wildly changes. We eliminated option C because there the derivative is undefined, and that can't happen if dy dx equals a continuous function. And here, for a given x, the slope varies. It's not an air ball. I figured it out, Jello. The answer is A. All right, so I aced the non-calc, I aced the calc. So there's the BC multiple choice. What I thought we could do next is for the AB folks, do the AB multiple choice, non-calc and calc, then we can try some free response. Does that sound like a plan? All right, so let me toggle over to AB. Anyone have a year that they'd like? The first thing I see in the chat's the year I'll do for AB. If anyone has a preference, now is your chance. Thanks for joining this. This is fun. I've never done a stream before, but I hope to continue. $2026 doesn't exist. Nice try. 2020 doesn't exist either because that was a COVID year. Okay, I'm just going to pick 2019. Oh, got you, Jello. No problem. I was airballing as well because I was stuck a bit, but the H of X was important. All right, so 2019 AB folks, this is for you. BC folks, pay attention because you still get an AB subscore. All right, so 2019 AB non-calc, let's speed run. Number 1 is an integral of x² over 4, so we bump up the power by 1 and divide by that new power. So that should be option B. Let me make this a little better. There we go. Yep. 2, which of the following is the equation in the tangent line? We need a point and a slope. When you plug in pi over 2, you get out 0. And then the derivative is negative sign. And when we plug in pi over 2, we get a slope of negative 1. So y minus 0 equals negative 1, x minus pi over 2, which I guess when you distribute the negative 1, you get something like this, which is option C, I'm sorry. 2 for 2, problem 3. I think we did something like this in the other one. So again, doing the AB only, the 2 would come down to give us 4. This would be sine root x to the 1. Then we derive sine to be cosine. Then we derive root x, which is 1 over 2 root x. So we're doing the power rule, then the derivative of sine, and then the derivative of root x. So that is option D. Okay. An integral. So notice that if we let u be x cubed plus 3x minus 5, the derivative is nice. It's 3x squared plus 3, which is 3 times x squared plus 1. Why is that nice? Because the x squared plus 1 will cancel. So we'll get a 1/3 1 over u, which is 1/3 natural log of what u was. So what are we looking at? Did I screw something up? Probably. Oh, my eyesight's so bad. I didn't see a, does that say cube there? Wow. I really need glasses. So sorry. I thought that was just x cubed plus 3x minus 5. There's a cube there. All right, so our work still holds. The derivative is going to work out great. We'll get a 1/3 out front, but sorry, I didn't see that cube. So that's u to the negative 3. We bump up to negative 2. We fix the power with a negative 1/2. So we need a negative 1/6 coefficient. So sorry, I didn't see that really small power. Negative 1/6, that looks like option D, right? I don't know why B is something that a student would pick. Yeah, so just because you have a denominator doesn't mean it's a natural log. There was a power there, so we had to do the anti-power rule. Still continuing with AB, concave up. So we need 2 derivatives. One would be 12x squared minus 4x cubed. Another derivative would be 24x minus 12x squared. We want to set that equal to 0. So we'll have 2 minus x. So our critical values are 0 and 2. To be concave up, we need the second derivative to be positive. So let's test a value like, oh, I don't know. Well, looking at the choices, that's nonsense and that's nonsense, right? There's nothing to do with 3 here. So let's test 1, say. When we plug in 1, 12 times 1 is 12. 2 minus 1 is 1. We'll get a positive answer. So, yep, that's what we need. It's between 0 and 2, which is option C. On to 6. And then 7. An implicit differentiation problem, A, B, and B, C for sure. Take the derivative of x, which is 1. The 1/3, if my eyesight's correct, comes down. Don't forget the chain rule. And the derivative of y is also dy dx. I like to plug in our point right now. So everywhere x is, which is vanished, would be 2. And everywhere y is would be an 8. 8 to the 1/3 is 2. 2 squared is 4, but that would be 1/4. So that means 1 is 3/4 dy dx. So dy dx should be 4/3, which is D. So if you're just joining us, I sped run, is that the past tense, through a BC Calc 2019 and aced the non-calc and calc We're now doing the 2019 AB for fun. All right, so you know the derivative of x to the fifth. What's the derivative of 5 to the x? It's 5 to the x times ln of 5. Don't forget, since the base is an e, you have to multiply by that, so that would be option D. 8. A limit. I think we had this on the BC as well. E to the x grows a lot faster than x squared or any polynomial, so this will head to 0, which is option B. 9. Let R be that region. What's the area? Okay, I want to figure out where they intersect, which means x squared would be 2x. One clear solution is 0 and the other is 2. So maybe a quick sketch would be good. 2x looks like that. And 4x minus x squared is a downward facing parabola. Something like this. Well, I missed a little. And sure enough, we intersect at 0 and 2, right? To find the area, we need to know which one's above the other. So clearly now with a good sketch, the parabola is above the line. So there's the upper function, and we need to subtract the lower function. That simplifies to 2x minus x squared. We integrate, plug in 0 and 2. Notice 0 is not going to end up with anything. 2 plugged in is 4 minus 8 thirds, which is 12 thirds, minus 8 thirds, which is 4 thirds. So that should be B. Correct. 10. Remember, you want to spend about 2 minutes per question. G is the function defined by that. What is G prime? So this is testing your understanding of the quotient rule. We derive the numerator with the denominator unchanged. We derive the denominator with the numerator unchanged, and divide by f of x squared. We now plug in 2. 2 times 2 is 4. What is f of 2? Looking at the graph, it's 3. Then what is f prime of 2? That's the slope. We go 1 over and 1, 2, 3, 4 up. When we plug 2 in, 2 squared plus 1 is 5. And f of 2, again, was 3, but squared is 9. So we have 12 minus 20, which is negative 8 over 9. That should be A. 11. An integral, I'm just going to divide through by x. X squared over x is x, and x over x is 1. Let's anti-derive. When I plug in 1, I get that. When I plug in negative 1, I get that. The halves cancel. I get negative 2. If I didn't make an arithmetic error, it should be A. Yep. I'm given a table which I can't read. Oh, we did this problem, if I remember. So we did this on the BC. Notice on the interval 8 to 12, the average rate of change would be 10 minus 2 over 12 minus 8, which is 8 over 4, which is 2. And by the mean value theorem, the average rate of change will be the derivative at some instant on that interval. So it would be 8 to 12, which is C. How are we doing in the chat? Are we enjoying this? The limit as x approaches 0 of sine x over e to the x minus 1. Be sure on the AP you show both limits separately. That limit is 0. And since e to the 0 is 1, that limit is 0 as well. We have L'Hopital's rule here because it's an indeterminate form. So you take the derivative of sine, take the derivative of e to the x minus 1. And now when we plug in 0 or approach 0, we get 1 over 1, which is 1. So it's A. So just be sure that you show each 0 limit separately before you use L'Hopital's rule. Also, it could be infinity and infinity. Infinity over infinity is indeterminate as well. We're on to 14. Maybe. 14, we have a particle. The acceleration is 12t. We're told some initial condition. So to get back to the position, we're going to have to integrate twice, right? So if a of t is 12t, integrating once would get us 6t squared plus some constant. And that's why they tell us this initial condition. The velocity is 2 when we plug in 0. So let's update our v of t now. Our position, which I'll call x of t, we integrate again. So that would be 2t cubed plus 2t plus some constant. Maybe I'll call this c1 and c2. The initial position is 5 when we plug in 0. So that's c2. So x of t would be 2t cubed plus 2t plus 5. That's option D. Pro tip. I'm not really exemplifying like how to use the choices, but what I could do to save a lot of work is plug in 0 and I better get out 5. All those choices work. But then I could take the derivative and plug in 0 and I better get out 2, right? So you could sort of backwards design, test the choices based on what you need to happen, and that avoids doing all this integration work. But D is it. 15, what is true? Is it continuous? Is it differentiable? Let's check continuity first. The limit as x approaches 5 from the left would be plugging in 5 to the upper function, which would be negative 25 plus 3. To the right would be considering the lower function, and negative 50 plus 28 is also negative 2. So it is continuous. So that's wrong, and that's wrong. A function can't be differentiable but not continuous, right? So like that makes no sense. Now differentiability. Since it's continuous, we can consider differentiability. When we take the derivative, we get negative 2x and negative 10. And let's consider both. Well, less than 5, we get negative 10, and greater than 5, we get negative 10. So sure enough, the slopes agree as well, right? So I'd say this is continuous and differentiable. That's A. Sweet. If you're just joining us, I solved 45 BC calculus multiple choice, got them all right, and I'm 15 for 15 on this AB exam. I know I'll mess up sometime though. We already solved this problem on the BC. The idea was to separate, integrate, plug in your initial condition. The natural log of 1 is 0. So C would be negative 1. So we'd have x minus 1. Multiply through by negative 1 first. Exponentiate. Rearrange, you get this. So that's B. 17. Here's a function, point of inflection. All right, so you got to know this, the fundamental theorem of calculus. What is someone saying to me? SD and so on says, Mr. B on the top of the question says what type of question it is. Well, it will not say that on the actual test, no. It will not give you any clues as to how to solve the problem. If g of x is this integral defined function, notice taking the derivative would just be that function, but with x plugged in. They will test multiple times on the test of understanding how to take the derivative of an integral. If we take the derivative again, we get 2x minus 5, which is 0 when x is 5 halves. And of course, before and after that 5 halves, I'll have a sign change. So we will have a point of inflection at 5 halves. That is B. Remember, a point of inflection isn't just where the derivative is 0. It's where a sign changes around that value for G double prime. We did that one. 18. Simple product rule problem with the chain rule. So we derive the first one with the second one unchanged. And then we derive the second. Secant's derivative is secant tangent. The derivative of the inside is 2, then times x cubed. Are they being clever in how they wrote the choices? No. It can't be A, right? We should have 2 separate terms. B is nonsense. Is C or D the right choice? I think D is it, right? Yep. So just be patient, use the product rule, the chain rule. You know that in your sleep. 19, we're given the position, which describes the motion. It's moving down the y-axis with decreasing velocity. It's moving down the y-axis with increasing velocity and so on. So let's plug in 1. 1 minus 4 plus 3 is 4, which is positive. So we're moving up the y-axis. So it's not the down ones. And if we take the derivative, that's 3t squared minus 8t plus 4. And I want to see if this is positive or negative. 3 minus 8 plus 4 is negative 1, which is negative. So our velocity... Oh, wait. My analysis is wrong. Just because y of 1 is positive doesn't mean we're moving up. That means we start at 4, right? 4 is where we begin, but now since the derivative is negative, we're moving down from there. So I was wrong. Why is it showing the right answer? That's annoying. So since the derivative is negative, we're moving down. And then if we take another derivative, plugging in 1 is also negative. So we're moving down and at decreasing velocity. All right, so don't fall for what I initially did. Y of 1 equals 4 is positive, but that just tells you where you start. The derivative is negative, and the second derivative is negative. That means we're moving down and decreasing velocity. Now is it going to show me the right answer when I click? No. Okay, good. We did this one already. You can't figure out anything about a product. You could figure out G itself, F itself, or a combination of F and G over that interval, but F times G you can't figure out. So C is something you can't determine. 21. All right, so this jumps out at me. This is the definition of the derivative. The function in question is the sine of 2x. So this limit just means what is the derivative of sine of 2x, which is 2 cosine of 2x. So that's option D. So remember the limit as b approaches a of f of b minus f of a over b minus a. That's a way of representing the derivative. And the limit as h approaches 0 of f of x plus h minus f of x all over h. Both of these represent the derivative of f at some instant. This is f prime of a. This is f prime at x. So please don't use L'Hopital's rule in that problem. That's like using a chainsaw to cut a sheet of paper in half. Shown as a slope field, which I can't even see, which differential equation could it be? So let me make this a little bigger. All right. So I'm noticing when we pick a y value, the slopes all look the same for that given y. So since the slope only depends on y, it can't also have x in it. So options A and B I don't think make sense. In option C, if y is negative, cubing a negative would be a negative slope. But notice when y is negative, we're still getting a positive slope. So I'm going to go with option D. We never get a negative slope, and it depends on y. Yep. On to 23. The base of a solid, okay, I want to sketch a graph. You should know what e to the x looks like. And the vertical line and the axes. So this is our region right here. Perpendicular to the x-axis is a square. So if I can figure out a way of quantifying that side length, I would square that to figure out the area of the square. That distance that I drew in green is just e to the x minus 0. So if I square that and accumulate all of those squares from 0 to 1, that should do it, right? So that's e to the 2x. Integrating is 1/2 e to the 2x. Don't forget the 1/2 to fix the chain rule. We plug in 1 and we plug in 0. So that should be option B. So please, with any of these volume or area problems, draw a sketch to help you out. And we just quantified how much that side length would be, which is e to the x, and we squared that. If it's a equilateral triangle or a semicircle, whatever, those just have their appropriate coefficients. I'm sure you can find that online. We'll go red. This one we did on the BC as well. Integrating the derivative gets you back to f. Plug in 12, plug in 0. 12 is -4, f of 0 is 4. That's -8, which is a. This is a lot of fun. Thanks for joining me on a Sunday. Hopefully you did something with your mom, though, Mother's Day. Or maybe she's watching too. This is a solution to which differential equation? Okay, so all the choices either have y prime or y double prime in them. I'm going to compute both. So here's y. Y prime would be 12 e to the 6x. The 5 disappears. And another derivative would be 72 e to the 6x, right? So the question is just how can I assemble these to get an equation to work? If I test A, y prime is 12 e to the 6x minus 6 of these minus 30. Does that get me 0? I get 12 e to the 6x minus 12 e to the 6x plus 30 minus 30. Well, that was nice. That should be A. So just test the choices, right? Plug in all the information you have, y prime, and if you need it, y double prime, and see which differential equation works. Don't solve that from scratch. What is the value of x at which the minimum occurs on the closed interval? Okay, so when we have a closed interval, just test the candidates. One candidate is 0, another is 1, the endpoints. Are there any other candidates? Well, let's take the derivative. That would be 4x to the 1/3 minus 2. Set it equal to 0. So x to the 1/3 would be a half. Cubing both sides gives us an eighth. So that's our last special candidate. And now we just plug these in to our function and see what we get out. If you plug in 0, you get out 0. If you plug in 1, you get 3 minus 2. We want the minimum, so it can't be this one. And then if we plug in an eighth, we get 3 times an eighth to the 1/3 is a half, to the 4th is a 16th, and 2 times an eighth is a 4th, which is 4/16. We get -1/16, which is smaller than what we got out there. So the value of x should be an eighth, which is B. Notice, like, you could throw that away immediately. That's not even a candidate. Cool. If you're just joining us, I'm speed running through practice AP problems. I did a full 2019 BC and aced it, and now we're on the AB non-calc. We are told that W of T, I should read it carefully. At time 0, it's empty. We start filling. After that, the depth is increasing at a rate of W of T. So W of T is the rate of filling. Which best interprets W prime of 2? Notice the units of W of T were already feet per hour. So if I take the derivative of that, I know the units will be feet per hour, or feet per hour squared. So I'm looking for something that says feet per hour. It can't be these. So if you just read at the end, see that feet per hour, feet per hour. It's one of those two. What are we told about W prime of 2? It's greater than 3. So what are the questions saying? 2 hours after the tank begins, the rate at which the depth is rising is increasing. And that's greater than 3. It's option C. D is saying over the first 2 hours. Yeah, it's at that moment that we're talking about, right? Not over an interval, but at that specific time. So it should be C. Yep. Will I ace this one? Let's see. Already a related rates problem, right? Remember, you're going to have this digitally, so you're not going to be able to like draw on the screen. So any diagram you want, redraw it. A person is always 30 feet away. This is rising, so maybe I'll call this y. And we know the rate of rising. That rate is dy dt, which is 2, positive 2, because it's rising. What is the rate of change in radians per second of that angle at the moment the balloon is 40 feet above the point? So our goal is to find d theta dt when y is 40. That's what we want to figure out. So with a related rates problem, have a good sketch, label the rates you know. Now we need an equation. Well, tangent would relate these two variables. Deriving tangent is secant squared. The derivative of 1/30th y is just 1/30th dy dt. Now let's plug in what we know. At the moment y is 40, we'd have a picture like this, which would make that 50, right? It's like a 3, 4, 5 triangle scaled up. The cosine of theta at that moment is 30/50ths or 3/5. So the secant of theta at that moment would be 5/3. I don't know what theta is, so that's why I did all that right triangle work now. But now I can plug in the secant of theta and square it. D theta dt we don't know. 1/30th is known, and dy dt was 2. So solve for d theta dt. It'd be 2/30ths times 9/25. That would just, 3 goes into this, right? And 2 goes into 10, 5 times, I think it's 3 over 125, b. Yep. So that's the sneakiest part of this problem, that you're like, wait, what do I do with theta? If you don't worry about theta as much as secant of theta, you plug that in. 29. How many vertical asymptotes are there for that? Well, if we factor using the difference of squares twice, this factor goes away, which creates a hole in the graph, not a vertical asymptote. This can be 0 at -2, and this can never be 0. So there should only be one vertical asymptote. A, right? Be on the lookout. They might ask how many asymptotes there are, not just vertical. And that would be 2, right? The one we just found, and the horizontal asymptote at y equals 0. Problem 30, and then we did it. For what value of b does this equal that? So immediately that 2 over n tells me that b minus a over n is 2 over n. Notice we're starting at 1. So b has to be 3. Is it that easy? Well, there is a value of b. I found it. And why did it format it in a weird way? What are the options again? I don't think it could be 2 only. Could b be any real number? No, I think it's 3 only. So a lot riding on this choice. Is it option B? I say B is it. Yes. Sweet, we aced the non-calc AB exam. How was that for everybody? We're on to the AB calc portion. We did this one on the BC. F prime being positive tells us F is increasing, and that's from 0 to 2 or 4 to 5, so that's option D. Sorry, getting thirsty. The height of an object is given by that. What is the velocity at time 3? So if you really want to avoid hard work, let's define h of t, or h of x, to be x squared minus 16 over x plus 15. And we want the value of h prime of, I can't read it now. Does that say 3? Yes. Ah, I didn't mean to click that. Sorry. I didn't see the answer, though. H prime of 3. So that's that. What's the velocity at 3? It should be 7 point something. That's option B. Pretty straightforward so far. Equation of a tangent line. Okay, I guess I'll build it in Desmos. All right, so to build the equation of a tangent line, we need to know a point and a slope, right? So they've given us the slope at -1, it's 2, and they've given us the point, -1 in, 4 out. So here's the tangent line. Y minus our known y coordinate is the slope. X minus our x coordinate, which is x minus -1. I'm going to add the 4 over just to get y on its own. And we want to plug in -1.2. So -1.2 plus 1 plus 4 is 3.6. That's option A. Next one. We saw this one earlier on the BC. To find the average value, we need to find 1 over b minus a and then integrate the function over those bounds. That's option B. Since h of t is already a rate, to find the average rate, we just found the average value of that rate. Here's a function. What is the value of g of 5? So this is testing your understanding of accumulating a rate. We know g of 2, so we'll start with that value. And then to it, we'll add how much we accumulate from 2 to 5. What are we integrating? The function they gave us, which is the square root of x cubed plus x. So by knowing where you start and knowing how much you change, you can get to your destination. 13.899 is option C. Next. Don't need calculator for this. F has a removable discontinuity at x equals 3, which is the graph of f. So a removable discontinuity is where the limit exists, but the function value there is different. In A, the limit doesn't even exist. B is a jump discontinuity. C is the picture, right? The limit exists, but the function value isn't that limit. So it'd be C. We're given all this stuff. What is 0 to 13? Okay, well, from 0 to 20, we can get by just adding up the first two. 8 plus -3 is 5, right? So the entire integral from 0 to 20 is 5. If we subtract away the part from 13 to 20, we'll be left with the part from 0 to 13, and 5 minus 7 is -2, so it should be A. We're given this. I think this was on the BC as well, if I remember. I don't remember the answer, though. So to be continuous, the limit and the function value at 3 should all match, right? So what I'm going to do is plug in 3 for x from the first one. So that's k cubed plus 3. I'm then going to substitute 3 in the second, because that's the limit from the right. I need to fix that so that's a 16, but I'll get that in a second. Minus 3, 16. Okay, so we've substituted 3 for the top one, the bottom one. Now the question is, what should k be? So I'm just going to test each choice. If k is 2.081, I get 12 point something and basically the same thing up to rounding. So it should be option A. So use the calculator to your advantage. There's no need to do any of this by hand. Based on the information, which of the following statements must be true? What are we told about this function? All we know is it's continuous. Okay, so if the function is continuous, two theorems apply: the intermediate value theorem and the extreme value theorem on some closed interval. Let's look at the choices. Must f have at most 1 0? Well, we can't make any claims about the maximum number of zeros just with a continuous function, so that's not true. Must we have a relative max? No. I think it's this one. This is just a statement of the intermediate value theorem, right? Do you agree that if we go from -9 to 1 to 5 and it's continuous, we'd have to hit 4 along the way? 4 is between -9 and 5. So the intermediate value theorem applies since we have a continuous function. It's C. 10. Here's a function. Which of the following is the x-coordinate of the location of a local max of f of x? And f of x is an antiderivative of this function. Okay, so this is sort of a silly question. F is an antiderivative, right? So if we integrate g, we'll get f. But then for f to have a local max, we need to take the derivative of f, which will be back to g. So let's graph this g function. Three minus square root x squared plus x plus 4 cosine x. Okay, so how does this help? Again, g is the integral of f, but then g prime would be back to f, which is what? Oh, I have it backwards. F is the antiderivative of g, so we'd integrate g to get f. But then the derivative of f would be back to g, which is this graph. What does it take for f to have a local max? F prime, which is g, has to go from positive to negative. Well, that occurs right here. So that should be the last option, D. Yeah. So we don't need to integrate because we're going to take the derivative of that. We're back to where we were. Here's a graph of f, which could be the derivative. Okay, well, from 0 to 2, the derivative is always the same. So we should have a horizontal line. And that slope is a positive number. So that can't be right. Right? We need a horizontal line at a positive number. Then what happens to our slope? Our slope is abruptly negative, reaches 0, then is positive. B is backwards. And yeah, it's not that at all. So it should be A. So just talk it through. 12, we're given the velocity. Let t equals be the time at which the particle changes direction from moving left to right. Well, if we change direction from left to right, that means the velocity should go from negative to positive. So first we need to figure out when that happens. And let's just graph this function. It's fine to type x, if that's easier. Okay, so here's the velocity function. It looks very interesting. Granted, it says only from 0 to 2, right? So we could restrict this, which looks a little better. So what's going on? From 0 to 2, the velocity is that. Let t equals b be the time at which the particle changes direction, moving left to moving right. So this function has to go from negative to positive, which happens right there. We can even record that number by hitting that little check. So we know the value of b now, but what's the question? What's the total distance the particle travels? I'm going to give this a name. Let's call this f of x, so I don't have to retype it. How do we find total distance? Well, it's the integral over our bounds, which is 0 to that number we found, 1.845 should be fine, of the absolute value of our velocity. So we should get 1.01. That looks like C. Yep. Folks, we're 3 questions away from acing the whole 2019 AB multiple choice. Here is a function for how many values of x in that interval is the instantaneous rate of change equal to the average rate of change. We did this on the BC exam, so I'll just talk through the idea. We graphed f prime. We found the average rate of change from 0 to 1.565, and we saw where those were the same, and I'm pretty sure the answer was just 1. Or was it 3? I think it was 3 times. I really don't want to retype all this into the calculator if that's possible. I think it was 3. Yeah. So graph f, type f of x, graph f prime of x, type f of 1.565 minus f of 0 over 1.565 minus 0. Graph that horizontal line in f prime, and they'll hit 3 times. Which of 20, 21, and 22 are possible values of g of 6? So I want to pull up my notability. I think I need sponsors for this. What would be a good sponsor for a calculus live stream? Monster Energy drink or something? Okay, so g prime is positive and g double prime is positive. We're told g of 3 is 12 and g of 5 is 18. I'm not trying to draw it to scale. And we're trying to figure out g of 6. Okay, so if g prime is positive, we know we're increasing. And if g double prime is positive, we're increasing at an increasing rate. So the graph so far would look something like that, right? Notice for a change of 2 this way, we've changed 6 that way. So the slope on average is 3. So if I change just by 1, I need to change by more than 3, right? Because this grows at an even faster rate than what I did here. Well, if I change by 3, I'd be at 21. So I think the only possible value would be 22. I might miss this question. Let's see. I'm going with B. Because we have to increase and at an increasing rate. Is it B? Yes. That's a cool conceptual question. Last one, will we ace it? We're given a function f and its derivative, and g is the inverse. Okay. Formatting of this is so janky. All right, g is f's inverse, and we're asked to find the equation of the tangent line for g at x equals 2. Oh, sorry, I don't know how to make this work so I can see the table at the same time. Okay, well, I guess I'll try to build it on the calculator then. Okay, so here's what we need to do. Even though g of x we're interested in when x is 2, that's the y value for f of x. Since f and g are inverses, 2 for x is 2 for y for the f of x function. Notice when we plug in 3 for x, we get out 2 for f of x. So that tells me that the point that I need is 2, 3 for this inverse function. Here's that logic again. 2 is an x coordinate for g. 2 would be a y coordinate for f, and that occurs when we plug in 3 for x. 3, 2 is a point on f. So 2, 3 would be a point on the inverse. Well, which has 2, 3 on the inverse? Not that one, not that one. Now we just need the slope. Well, what is the slope? Not when x is 2, but when x is 3. In the table for f, it's 5, right? Remember, the derivative of an inverse is the reciprocal of that slope. So it should be 1/5. That's C. We aced the entire AB 2019 multiple choice. Sweet. So now what I've done is the 2019 BC and the 2019 AB. I thought it would be cool to do some free response. And I've got a lot. Someone in the chat tell me, we'll do BC first. Tell me a year. Do you want to do 2013, 2012? I've got all the way back to 2012. What's a year you want to try for the BC free response? I have no way of knowing if there's anyone even on this chat or on the stream anymore. Is anyone still watching? Someone's there. Thank you, Daffy. Let's try the 2014 BC. Oh, wrong thing. Sorry. That was a full test. Apologies. I only went back to 2017 for the free response. So what's a year you want to try? The other thing I had was not just free response. 2019 it is. 2019 free response. Let's do it. All right. Fish enter a lake. Fish leave a lake. E and L are both rates in fish per hour. Time is in midnight. How many fish enter the lake over the first 5 hours? Well, that's us integrating our E of t function. And I'll pull up the calculator in a second. What is the average number of fish that leave the lake? So this is an average value. It's still from 0 to 5, so we need 1 over b minus a. And we evaluate that. C, what is the greatest number of fish in the lake? So the greatest number of fish occurs when E of t and L of t, well, a candidate occurs when E of t equals L of t. That would be a critical value that we need to find. Granted that we have a closed interval, right, 0 to 8, we need whatever t we get from this and the endpoints, and we'll make a quick table. So this is a candidates test idea. We need 0 and 8 and whatever value I find. I'm just going to pull up the calculator in a second. And is the rate of change in the number of fish in the lake increasing or decreasing at 5? Well, the rate of change of the number is just what comes in minus what leaves. And to see if that rate is increasing or decreasing, we just figure out E prime of 5 minus L prime of 5. Okay, so now I'm going to pull up the calculator. It's a good habit to define functions. So I'm going to call this one E of x, maybe. That's 20 plus 15 sine pi x over 6. And L of x is 4 plus 2 to the power of 0.1 x squared. I don't really need to see those. So now let's integrate from 0 to 5 of E of x dx. So the first one should be 34 fish or so. The next one is 1/5 integral 0 to 5 of the L function. And that's 6.059 fish. C, we want E and L to be the same. So I'll graph those. And let me be sure I'm in radian mode. Yep. Why is that graph so weird? That graph looks funky, right? Why would that not be graphing properly? Something is weird with Desmos. If I graph sine of x, that seems fine. If I graph 15 plus sine x, that seems fine. What was the function again? 20 plus 15 sine pi x over 6. That was super weird. It's making me doubt the first answer then. Wasn't that strange? Like it graphed it. Oh, here's why. If I call it e, it's thinking it's the number e. I'm going to call it f of x. So yeah, that's something to look out for. If you type e of x, it thinks it's the number e. So I'm resolving number 1. It's from 0 to 5 of f of x dx. Yeah, 146 is the right answer. All right. So be on the lookout. Never call a function e of x. L of x should be okay, right? Let's just double check that. 1/5 integral 0 to 5 L of x dx. Fine. All right, so now I graph the two functions. Don't need these anymore. And what were we interested in? We want to know where e and L can be the same. That occurs right there at 5.945. So that's our last candidate. And now what do we need? We want to know the greatest number of fish in the lake. So maybe I'll call that n of t, the number of fish. How do I find the number of fish in the lake? I integrate. There are no fish to start with, right? Yeah, we're not told how many fish there are at the beginning. So we're going to integrate from 0 to our value that we want to try of what enters minus what leaves. So from 0 to 0 would be 0. If we go to 5.945 of what I'm calling f of x minus L of x, there are 123.74 fish at that moment. And if I go up to 8, there are only 55.24 fish or so. So what time is the greatest number of fish? 5.945. So what did we do? We tested the endpoints 0 and 8. We also tested any critical values. That's where those two rates are the same. And at that time, we had the most. The justification is literally this table. It's called the candidates test. Finally, we said, is the rate of change increasing or decreasing? Well, the rate itself is e of t minus L of t. To see if that rate is increasing, we need to take its derivative. So we'll take f prime at 5 minus L prime at 5. That number is negative 12.99. Since that number is negative, that tells us that that rate is decreasing. So here's our explanation. Explanation, excuse me. It equals 5. The rate of fish in the lake is decreasing since e prime of 5 minus L prime of 5 is negative. All right, so technical difficulties, never use e of x. Other than that, pretty straightforward. And this would be an A-B common question. 3 of the 6 questions on the A-B and BC are the same. All right, a request for graphical analysis. Sure, let's do it. Graphical analysis is no calc often. So would this one be okay? Inexorable something. So this would be an A-B common problem probably as well. Here's a continuous function. It's the graph of f. They tell us some things about lines and quarter circles. And it is known that this occurs. That's going to come into play later, maybe. I haven't solved this problem. We'll see. If the integral from -6 to 5 is 7, find the value from -6 to -2. Show your work. Okay, well, from -6 to -2 needs to take away the part from -2 to 5, right? So let's integrate from -2 to 5. Well, we'd have positive 1/2, minus 1/2. What would this area be? We go 2 over and 4 up, so that's truly at 1/2. So this area would be 1/2 times 1. Oh, but this isn't 1/2, right? Let's think carefully about this. So the slope here is 4 up and 2 over. So the slope is 2. And the y-intercept is -1. So yeah, when we get out 0, this is at an x value of 1/2. I just wanted to confirm that that was at 1/2 and not something like 1/3 or something. Okay, so what's the slope, or what's the area of this little triangle? It's 1/2 -1 times 1/2, which is -1/4. The area of this triangle is 1/2 times 3/2 times 3, right? It's 3/2 wide and 3 tall. So that's 9/4. And then how do we find the area of that remaining part? Well, the area of this entire square would be 9. So this is 9 minus the quarter circle. And the circle has a radius of 3. 3 squared is 9. Wow, that's a lot of computation. So let's put it all together. From -2 to 5 is 1/2, minus 1/2, minus 1/4, plus 9/4, plus 9 minus 9 pi over 4. I'm getting 11 minus 9 pi over 4. I am reading the chat, yes. Hello, Joseph. 11 minus 9 pi over 4 is the area from -2 to 5. So we need to subtract 7 minus that to find the area that's remaining. So that should be 9 pi over 4 minus 4. I might have made an arithmetic mistake, but that's the idea. Find the area that you can see, subtract that area from 7. That's the area that we wanted. Okay, evaluate this. So I'm going to break this up. Okay, integrating f prime is f at our bounds. And integrating 4 from 3 to 5, well, that's just a rectangle that's 2 wide and 4 tall. So that's an area of 8. Okay, so now we just look at the graph. What is f of 5? This is the graph of f, and f of 5 is 0. What is f of 3? They tell us that, right? It's 3 minus root 5. And then we add 16. So this would be 2 root 5 minus 10, I think. plus 10. Let's check that. So you distribute the negative. That's root 5 minus 3. So now we have 2 root 5 minus 6 plus 16 is 2 root 5 plus 10. Yeah. The function g is this. Find the absolute maximum. Again, candidates test. We need x and f of x. Here's our 2 endpoints. Are there any other candidates? Well, since g prime is f, where could that be 0? F can be 0 at -1, at 1/2, and at 5, right? So we need to add -1 and 1/2 to our table. Okay, so now we need to figure out these areas. From -2 to -2 is an area of 0. From -2 to -1 is a half. From -2 to 1/2 is -1/4. And all of that area we painstakingly calculated from -2 to 5 was 11 minus 9 pi over 4. What is the maximum value? Well, it can't be these. How big is 11 minus 9 pi over 4? That's 44 minus 9 pi over 4. Pi is about 3, right? So this is about 44 minus 27 over 4. No, I'm good.
Are you sure?
Yep. That's definitely bigger than a half, right? So the absolute maximum value of g will be this. The justifications, the candidates test. And in D, find the limit. Well, we can hope for the best. The limit as x approaches 1 would be 10 minus 3 f prime of 1. What is f prime of 1? Well, that's the slope, which we figured out is a slope of 2, right? 4 up and 2 across. So this is promising, right? I was expecting we get 0 and need L'Hopital's rule or something. What's the limit as x approaches 1 of f minus arctan? Well, that would be f of 1 minus arctan of 1. F of 1 is 1. And the arctan of 1 is pi over 4. So we just divide. That's a fine answer. If we multiply everywhere by 4, we can get 16 over 4 minus pi. You don't have to do that. 4 over 1 minus pi over 4 is fine as well. Okay, so I forget who requested a graphical analysis problem. I maybe made an arithmetic error, but that's in essence what you have to do. I don't know. How about I start taking requests? Is there a particular topic that you want to review? Or I could do another multiple choice. Optimization, okay. I would say optimization is really more tested in terms of candidates than an applied problem per se. So I would say that we did that. We did the candidates test just in this last problem, right? I definitely want to do a series problem. Let's try this one. Okay, so problem 6 is guaranteed to be a series question. Maybe let's do a few of those for the BC Calc people. So problem 6 will absolutely be a series question. Let's read this one. A function f has its derivatives as shown. So we're told f double prime of 2, f triple prime of, we're told f double prime of 0 is 3. F triple prime of 0 is this. in 4 derivatives of 0 is 54, right? We're told those from the table. A portion of the graph of f is shown. Since 0 is tending to be our center, let's write down what the graph tells us. Well, f of 0, we know, is 3. And what's the slope at 0? Well, we go down 2 over 1, so that's -2. So we found out a lot about f, either from the table or from that graph. Write the third degree Taylor polynomial about x equals 0. Remember, that's called a Maclaurin series. I like to call that P3 of x. What do? We take f at 0. We add the derivative times x, the second derivative times x squared, but don't forget the denominator, 2 factorial, and then 3 derivatives x cubed over 3 factorial. Now we just plug in what we know. F of 0 was 3. F prime was -2. F double prime was 3. So 3 halves. And F triple prime is -23 over 2, but over 6 would be -23 over 12. So there's our third degree Maclaurin polynomial. Write out the first 3 non-zero terms from the Maclaurin series of e to the x. That you should know immediately. Then it'd be x cubed over 3 factorial, x to the 4th over 4 factorial, and so on. Write the third degree Taylor polynomial for e to the x times f of x. So we're going to have to take what we wrote down times this. And I'll just go up to, I probably don't even need to go up to x squared. And we're just going to distribute. So 1 times 3 is 3. Maybe I multiply each term here by that, and then each term here by that, and so on. So then we'd have 3x. We'd have 3x squared over 2. Now let's multiply each of these by -2x. We'd have -2x, what am I saying? -2x, -2x squared. And I don't need any more, right? Because it says just the first 3. So I could keep going, but I don't need to. And lastly, let's have this multiplied by 3. That's 3x squared over 2. There are more terms there, but they'd be x cubed, x to the 4th, and so on. So now let's just total it up. We get 3 plus x. 3 halves plus another 3 halves is 3, but -2 is 1. So that would be the first 3 non-zero terms. Just multiply out enough terms of e to the x by the answer in part A, distribute, collect the 3 non-zero terms, you did it. Let h be this function. Use the Taylor polynomial found in A to find an approximation for h of 1. Well, in A, we have this polynomial. Technically, I should be writing t's, though. So let's integrate. Notice 0 is going to knock out that lower term. So the integral of 3 is 3x. The antiderivative of -2t is -x squared. The antiderivative here, we bump up to 3 and divide. So that's 1/2 x cubed. And when I bump up to 4 and divide, that's -23 48ths x to the 4th. Use that to find an approximation for h of 1. This is h of x. So just plug in 1. 3 minus 1 plus 1/2 minus 23 48ths. And you don't have to do arithmetic ever on the free response. So I can just stop there and I'm done. You could get a common denominator if you want. It is known that the Maclaurin series for h converges to h of x for all real numbers. So our interval of convergence is -∞ to infinity. It's also known that the individual terms of h of 1 alternate in sign and decrease in absolute value to 0. Use the alternating series error bound to show that the approximation in C differs by h of 1 by at most that. Okay, so the alternating series error bound says if you add the first few terms, say the first n terms, the error is no greater than the next omitted term in absolute value. So I'll say this again. If you add, say, the first 3 terms, then the error is no greater than the absolute value of the 4th term, the next one you would have left out. So what is this saying? We use the alternating series bound to show that the approximation found in part C differs from h of 1 by at most 0.45. So what did we do in this? What is this h of x function? It's this, right? And the one in part A was going up to the x cubed term, right? So what I'm going to do is figure out what the next omitted term would be and use that to help me with my error. If I continued on here, what would the next term have been? Well, that's why we're told this, right? So if I go to the x to the 4th term, the next omitted term would have been 54 over 4 factorial x to the 4th. But careful, this is the next term in this f function, right? It would have been 54 x to the 4th over 4 factorial. So the next term in h would have been the antiderivative of that. So that would be 54x to the 5th over 16 times 5, right? Not 16, I'm sorry. 4 factorial is 24 times 5. So that's 54 over 120, x to the 5th. What x were we plugging in? 1. So our error is no greater than 54 over 120 times 1 to the 5th, which is 54 over 120. We need to show that that is no more than 45 hundredths. Well, what is 54 over 120? You know what's amazing? 54 over 120, you could reduce by, I don't know, let's say 4, or what am I saying? Let's say 6 to start with. Isn't 9/20ths 54 over 100? So we just made it. That is exactly our error. So let's recap. We looked at the next omitted term in f. We integrated that to build h. So that's the next omitted term in h. So our error is no greater than that when we plug in 1, which is exactly 0.45. Sometimes on the AP, they'll say, show that the error is no greater than like 1/2. And since our error bound is 45 out of 100, of course, 45 out of 100 is less than 1/2, right? Sometimes it's not like strictly going to make it, but here it was right on the nose, 45 100ths. Zane asked for a series, as did Rigatoni. Can we try another one? Do you have a preference of year? I could do 2021, 2022, 2023, 2024, 2025. How many people are watching this? $2024? Sure. So let's go to number 6, guaranteed to be a series question. The Maclaurin series is this. It converges to f for all x in the interval of convergence. So we're not necessarily told the interval of convergence is -infinity to infinity. We're told that the radius of convergence is 6. So already I know that the center is 0. And I can go at most 6 units on either side. So the interval of convergence is some sort of -6 to 6. I just don't know what the endpoints are. Part A says, what happens when x is 6? So we're just testing this right endpoint. I'll do my best to squeeze it in. If x is 6, well, 6 to the n over 6 to the n cancel, and we get this. Well, this is very much like the series of 1 over n, right? If you just pick n and n squared, and this we know diverges. It's a harmonic series. But what does that mean about the series in question? We need to show by some sort of comparison test that this has to diverge as well. You can do that 2 ways, actually. You can use the limit comparison test, or in this case, the direct comparison test. The limit comparison test you see more frequently, so I'll do that, where you take what our series was divided by the easier sequence that we were summing. That becomes n squared plus n over n squared, which of course has a limit of 1, right? Those degrees are the same. What are we hopeful in the limit comparison test? If the limit is some non-zero number, positive number, then we know that the easier series does the same thing as our original series. Since the limit is 1, that means the original series also diverges by limit comparison. So what is the answer? Diverges. We plugged in 6, found that it's essentially like the harmonic series, which diverges. So f would do the same at x equals 6. It can be shown that all this stuff equals that, and that the first 3 terms sum to that. So this is an error-bound question, right? They plugged in -3. They're saying that's the value that we got by adding the first 3 terms. Show that the error created is less than 1 over 50. Well, this is an alternating series, right? When we plugged in -3, it is now alternating. When we have a converging alternating series, we can use the alternating series error bound, which we talked about before. The error, this is the error here, is no more than the next omitted term. Well, since we went to the 3rd term, we'll plug in 4. When we plug in 4 for n, we get 4 plus 1, 5. 4 squared is 16. And -1/2 to the 4th. Always, we don't care about negative error, right? That doesn't make sense. So we take the absolute value, and we get 5/16 times 1/16. That's 5 over 256. Is 5 over 256 less than 1/50th? Yeah, because 1/50th is 5 over 250. 5 over 256 is certainly smaller than 5 over 250. So this, again, is lots of words for just essentially looking at the next term in absolute value. That's your error, or a bound of the error. Find the general term of the Maclaurin series for f prime. So if this is f, we're going to take its derivative. And it's simple. Just do the power rule. All this n stuff stays the same. X to the n, that n would come down, and now it's to the n minus 1. This n can cancel with that n, so we end up with this. So that is the Maclaurin series for f prime. Find the radius of convergence. I already know the answer. If the radius of convergence for f was 6, taking the derivative won't change that. The radius of convergence is still 6. Let's prove that with the ratio test. So we're going to bump up each n by 1. And multiply it by the reciprocal of what we currently have. And this limit needs to be less than 1 to converge, right? So what can we do? I notice that this and this multiply to an n squared, and this multiply to an n squared. Well, n squared over n squared would have a limit of 1. So I can ignore all those n terms. All of these x terms delete almost all of those x terms with an x left over. So we'd have an x there. And 6 to the n and 6 to the n plus 1 leave a 6 left over. So that gives us the absolute value of x over 6, which has to be less than 1. And sure enough, our radius of convergence is 6. So what's the takeaway? Deriving or integrating doesn't change the radius of convergence. D, use the ratio test again to determine the radius of convergence of this new series. Lots of ratio test work here. We'll bump up each n by 1. And then we'll flip this around. Let's simplify. Again, we have the same interaction, right? That all of this in the wash works out to a limit of 1. Now we have n cubed versus n cubed. That still goes to 1. Here we have a surviving 3 in the denominator. But be careful, this divided by that is x squared. We have 2 more x's up top than the bottom. Well, that needs to be less than 1. Let's multiply 3 over and square root. Our radius of convergence is root 3. How are we doing, Zane and others that wanted to see some series? We could do more if you'd like. Can we do another one? How about, wait, where did all the ones go? Let's import. Thank you. How about 2021? Zane, where are you from? All right, 2021, number 6 is guaranteed to be a series. G, we can take all its derivatives. Here's a Maclaurin series. Great. State the conditions necessary to use the integral test. Okay. That seems random. To determine the convergence of this series. So 2 tests for sure have conditions that you need to check. The integral test is one of them. To use the integral test, you have to check that the function we're considering is positive, that it's continuous, and that it's decreasing. The function that we're considering is 1 over e to the x. So just think of x where n is. Well, is 1 over e to the x positive? Yeah, e to the x is positive, so 1 over that is 2. Is it continuous? Well, e to the x can never be 0. And the bigger x gets, the smaller 1 over e to the x gets, so we're decreasing. So those are the conditions. Now, how do we use the integral test? Instead of a series, we consider an improper integral from 0 to infinity. If this integral converges, so does the series. If the integral diverges, then so does the series. You get a point if you write this as a limit. And now let's integrate. E to the negative x antiderives to negative e to the negative x. Don't forget to undo the chain rule. plug in b, and now we're going to add, right, since we're subtracting a negative, plug in 0. If b goes to infinity, remember this means 1 over e to the b. The bigger b gets, the bigger the denominator gets, but the smaller this will be. So this is going to 0, and we get 1. So does the integral converge? Yes. What does that tell us about the series? It converges as well. So the integral test is check those 3 boxes, do the improper integral instead. Whatever answer that is, the series does the same thing. B, use the limit comparison test to show that that converges absolutely. So absolute convergence means throw away any negative terms and make them positive. So if we do that, we're just considering this. Right? We just took the absolute value and now it's not alternating anymore. So we're comparing this and this. Well, we just proved that this converges, right? The limit comparison test wants us to say this converges too. What one does, the other should do. But to show that they're compatible, you need to take the limit of one divided by the other. That flips e to the n around. These are of the same magnitude of growth, so it'd be 1/2. The limit comparison test just wants any positive number. If you get a positive number in your limit, that's saying that the 2 series are compatible. What one does, the other does. Since this converged in part A, this must converge as well. So series converges absolutely. The absolute part is just we took the absolute value of our terms, and that's what this new series was. I'm running out of space, sorry. Determine the radius of convergence for G. What was G? G is this original one. How about I do it up here? So you have to know the ratio test. We've seen that many times. To find the radius of convergence, and thus the interval of convergence, we need to do the ratio test. So we bump up every n by 1. And multiply by this flipped around. And that's a limit we need to figure out. Well, if we cherry pick those, that ratio is just -1, and the absolute value will take care of that. If we cherry pick these, that just leaves an x left over. And what is this limit? Well, that extra +1 in e, I could write like this. So I see 2e to the n and another 2e to the n, but do you see that extra e there? That tells me that this limit, getting rid of the negative, would be x over e. And that has to be less than 1, which means absolute value x is less than e. So the radius of convergence should be e. Adam, yes, great question. If the limit comparison test, if the limit in the limit comparison test gives you 0, that's saying the denominator is growing so much faster than the numerator, so they're not compatible. That just means we can't compare our original series to that new candidate. So we either need to find a better candidate where they are compatible or try a different test. Also, if we try the limit comparison test and that limit works out to infinity, that means the numerator grows so much faster. They're not compatible either. That's why it has to be a number, a positive number. D, this is probably an error-bound thing. Yep. The first 2 terms are used. Let's write out those first 2 terms. If we plug in 0, we get 1 over 2 plus 3, because e to the 0 is 1, right? And if we plug in 1, we'd get negative 2e plus 3. And that's where we're stopping. The alternating series error bound says, consider the next term. What's the one you would have left out? So let's plug in 2. So that's our next omitted term, right? Use the alternating series error bound to determine an upper bound for this error. Well, that's it. Our error is no greater than that next omitted term. Technically an absolute value, but 2e squared plus 3 is positive anyways. If the next omitted term was negative, we would throw away that negative sign. Okay, there's another series. I think I'm going to try another. Oh, so a number basically means that the series is realistic, close together, and they're not quite convergent. What the limit comparison test is saying is I have this messy series. Here, I'll do an example. Say I have this gross looking series. The limit comparison test is often used when you have a really messy looking series and you simplify to just like the core dominant terms. So when n is really big, essentially this is going to act like n squared over the square root of n to the fifth. So this series wants to behave like this, which of course is 1 over n to the 1/2, right? Well, what do we know about 1 over n to the 1/2? This is a p series. And since p is less than or equal to 1, by the p series test, we diverge. This simpler series diverges. What would we like to say as a consequence about the original series? Not that it converges, but it does the same thing as our simpler series. So we hope to say that this diverges too. They go hand in hand. But how do I show that the easier one and the original one do the same thing? That's where the limit comes in. So I'm going to take the original and divide it by the simpler one, which of course will multiply by n to the 1/2 over 1. So now we're looking at n to the 5/2 plus n to the 3/2 plus n to the 1/2 over this. But when n is really large, we're essentially just dividing n to the 5/2 by itself. That's 1. Since we got a positive number, that's saying that they're in like 1-to-1 correspondence. For large n, they're essentially the same thing. So if one diverges, the other has to. So the reason I push back a bit, Chavin, is you're saying they're close together, yes, but therefore convergent. No. What one does, the other does. If one converges, then the other does. But if one diverges, then the other does. It's not proving convergence only. Zane wants an example of direct comparison test. Sure. Say 4 plus 2 cosine n over n squared. Well, the most cosine could be is 1. 2 times 1 is 2, plus 4 is 6. This converges because p is 2. 2 is bigger than 1. So the direct comparison test is very finicky about how they compare. If our series is less than or equal to something that converges, it can't diverge, right? Meaning like go to infinity. So this has to converge also. Here's an example where the direct comparison test would fail. Do we agree that this is smaller than n over, let me put a square here, than n over 5 n squared, right? This is smaller than that. That simplifies to n over 5. 1 over 5n. This diverges because it's essentially a harmonic, right? But this doesn't help me, right? Even though I have a smaller series, in comparison to a larger diverging series, I don't know what the series in question does. If the series I'm inspecting is smaller than a diverging series that's pushing off to infinity, it could be infinity or a number, I don't know. So here's where the direct comparison test is annoying. I wish this was a greater, and then I could have made a determination. That's where the limit comparison test saves you. If you take the limit of one over the other, this simplifies to 5n squared minus 5n over 5n squared, which is a limit of 1. That shows these are compatible. What one does, the other does. So now I can say that this diverges. So the direct comparison test used sparingly, only if you compare in the way that you need. The limit comparison test is more rough around the edges. So hopefully that answers Clubus's point. Clubus asked about the Lagrange error bound. You usually have to do multiple derivatives. So the Lagrange error bound, here's both bounds. The alternating series test bound says your error is no bigger than the next omitted term. So if you add up the first 3 terms, just look at the 4th term. If you add up the first 7 terms, look at the 8th term. Take the absolute value, though. We don't care if we never want negative error. What Lagrange says is your error is no greater than the next term, sort of. Remember, to generate any Taylor series term, you take so many derivatives. So I'm looking at the n plus first now, if I stopped at the nth one, times x minus your center, now to the n plus 1, not n anymore, over n plus 1 factorial. The one catch about Lagrange is it's not quite the next term, because this could be any value you want, z, provided z is between your center and the x you're plugging in. So z could be any value here. So I want you to see the connection. Alternating series error bound says, look at the next omitted term. Lagrange is almost doing that, right? This looks like how you generate any term in a Taylor series. It's just this usually is your center. Now it can vary. It can be any number from your center to the x you're plugging in. To handle this, what you often do is just say the maximum value where m is the max of that n plus first derivative over your interval in question. So the way this is often assessed is either if you have like a sine or cosine function, the most it could be is 1, or maybe they give you a table or a graph, and it's clear that the most that n plus first derivative can be is some value, and you just plug that in. So the error bounds are essentially the same. Just look at the next term. There's just a little catch with Lagrange. You're not plugging in the center. You're plugging in some value from the center to x. Just find the biggest it can be. LCT, limit comparison test, will always work if you're good at picking an easier series to compare to. But if you pick something totally random, then that limit might be 0 or infinity, meaning your choice to compare to wasn't a good choice at all. The max value of that n plus first derivative is either something that you can infer from a table. I might be able to find an example of that. Or they just tell you the most it could be is some value. Or if you're working with sine or cosine, any number of derivatives of sine or cosine is 1. So hope won't be lost there, Chavin. Like you'll have something to figure out. If you add up the first 3 terms, you'll know what that next derivative would be at most. They'll either tell you or give you a table where you can figure that out. Okay, what should we do next? I still have more energy. 12 people are still watching. Oh, no one sent me any Venmo. Oh, that's okay. I wasn't expecting it anyways. Any other requests? Polar, sure. Does this have a polar question? Here's one. No, that's not polar. What am I saying? Polar is pretty rare. I would say you're almost guaranteed number 2 to be a 2D motion problem if you're taking the BC. Polar doesn't pop up that frequently, at least on the free response. Let's see if we can find one. That's not polar, no. Yeah, notice 2 again is a motion problem. 2019. No. Ah, there we go. All right, so should we try 2, Zane? Here's a polar curve. Find the area. Well, they're nice. They already told you the bounds, right? What helped my students a lot is think of it like a lawn sprinkler. As you rotate, you're shooting out from the origin. So this is how the polar curve is being shaded. With each new angle, we go some distance out, and we cover that whole region with how far the sprinkler shoots out. How do you find a polar area? That's 1/2 integral r squared. Well, they told us the bounds, 0 and root pi. Don't forget to square this function. But we have a calculator, right? So just, I'll leave it to you to evaluate it. So in this case, the bounds were simple. What is the average distance from the origin to a point on the polar curve? Notice average, right? This is asking the average distance from the origin. The distance from the origin is the radius. So this is just an average value question. It's 1 over b minus a. The average value of what? The average value of the distance from the origin, but the distance from the origin is the radius. Calculator. So in A, the area, we needed 1/2 radius squared. Bounds were given. B, it's up to us to realize the distance from the origin is the radius. So we just did 1 over b minus a, integral of the radius. C, there is a line through the origin with a positive slope m that divides the region S into 2 regions with equal area. So maybe this is my line of slope m. The one catch is polar is all about not x's and y's, but r's and thetas, right? So it'd be great if I could have that angle be associated to the problem, not the equation of the line. Well, if you take the tangent of theta, that is opposite over adjacent, right? If the slope is m, wouldn't opposite over adjacent have to be m? So the tangent of theta is m. That means our angle is the inverse tangent of m. So what are we asked to figure out? There is a line through the origin with slope m that divides the region into 2 equal areas, right? But do not solve an equation that helps us solve for m. So if we do our polar area from 0 to that angle, that should be half the answer we got in A. So I would say if we integrated from 0 to arctangent of m of our radius squared, that should be, that area should be half of what we got from part A. Don't let the halves confuse you. This half is here due to polar area. This half is here because it's half that total area. You could also write something else, right? Instead of half the total area, you could just say it's the remaining part. So if you integrate from 0 up to that angle in question, you get the same area as if you integrate from that angle in question to radical pi. To me, it's easier just to say it's half the total area. Okay, let A of k be the area of the portion of S that is also inside the circle. Find that the limit of what's shared as k goes to infinity. Let A of k be the area of the portion of S that is also inside that circle. So that circle looks like this. If k gets bigger, that circle would look like this. If k gets bigger, that circle would look like this. It's all along the positive x-axis. So how are we going to express that shared area? Sorry, I'm responding to a message real fast. Sorry. Well, it would eventually, right, if I have like a gigantic circle, it would include everything up to there, right? This little part to the left of the y-axis, I'll never be able to get from that circle. But a gigantic circle like this, as that k goes to infinity, would be able to include all of this, but not that little part to the left. Well, that just says go up to pi over 2. We're going to go from 0 to pi over 2. Of 1/2 radius squared. And we have a calculator. So that one's probably the most conceptual, but you have a calculator, right? You could type in that radius expression. You could type in these circles, like 2 cosine theta, 6 cosine theta, 100 cosine theta, and you'll see that you're going to cover all of that quadrant 1 portion. So we figure out what that answer is. Sure. 2018 free response 5. Let's see if I have that ready. Is this the one? Okay. They're kind and they even tell you what the graphs look like. That's pretty common if it's on a non-calc. R equals 4 is this plain old circle. And this curve is the more interesting one, 3 plus 2 cosine theta. Okay. They already tell us where they intersect. Of course, we could set them equal and solve, but we're told at this angle spoke, pi over 3, and at this angle spoke, 5 pi over 3, they collide. Part A, write an expression for the area R. Notice that that R is trapped between the circle, which is farther out, and the cardioid. Well, I guess that dimpled limacon, if you want to be technical. But we want to find this gap in area, right? So we're going to have to either write 2 integrals or treat the fact that there are 2 radii. 4 is farther out than 3 plus 2 cosine theta. So one way to do it is 1/2 integral. Let's just cover everything, right? From pi over 3 to 5 pi over 3 of the outer radius squared minus the inner radius squared. This should remind you of like upper minus lower that you did in AB Calc to find the area between two curves. Or another option, always look for symmetry. We could just go to pi and stop and double it. Sorry, I'm running out of space. The integrand's the same. The idea is just go to pi, that's half the area, times 2. Exactly, Adam. Yep. So that's part A. B, find the slope of the tangent line. I wish I had more space. So we want dy dx, right? Well, first we need to find what x is, what y is, and go from there. X, remember, is r cosine theta. Y is r sine theta. R in this case is 3 plus 2 cosine theta. So we plug that in. And now we're going to derive carefully with the product rule. The derivative of this is -2 sine. Leave this one alone. The derivative of cosine is negative sine. That's a mess, but when you plug in pi over 2, every cosine will drop out, right? The cosine of pi over 2 is 0. So that goes away. We get -3 times 1, since sine of pi over 2 is 1. We're going to do the same thing now and derive this. We'd have -2 sine times sine. And then that's left alone, but cosine. When we plug in pi over 2, use good notation on the free response. Now I'm showing I'm plugging in pi over 2. Every cosine disappears, so the second term is 0. And every sine is a 1. So that should be -2. What do we now do to find dy dx? We divide dy d theta by dx d theta. So that's -2 over -3. That's 2/3. So that's the answer to B. Part C, a particle is moving along that curve, so we forget the circle. The particle moves in such a way that the distance between the particle and the origin, well, that's just r, is increasing at that rate. So they've just told us dr dt. It's +3. Find the rate at which the angle changes with respect to time. Our goal is d theta dt at pi over 3. So let's write down our curve. This is just like related rates. Let's take the derivative. I'll do this in another color. This is getting complicated. Hot pink, how about that? I'll do purple. Okay, so we take the derivative, that's -2 sine theta, but careful, times d theta dt. What do we know? dr dt is 3. The angle in question is pi over 3. The sine of pi over 3 is √3 over 2. And there's the d theta dt we want. So it's 3 over -√3, which you can rationalize. Units of measure. Well, theta is always measured in radians. And in this case, time is measured in seconds. So the idea in A was the area was trapped between two curves. 4 was farther out than 3 plus 2 cosine theta. You could either do the full angle sweep from pi over 3 to 5 pi over 3, 4 being squared first, or you could do half that times 2. In B, we found dy d theta, dx d theta, and divided them to get dy dx. And in C, it looked really hard, but you just take the derivative with respect to t, plug in what you know. You could find the area of the circle, back to part A. You could find the area of the circle, which is 16 pi, right? We know that from geometry. But then you're going to have to subtract out this part, which I think is more work than what we did. Why is it more work? Because that part that I shaded partly is bounded by the circle, and the other time is bounded by this other curve. So the work to find that green area is a lot more involved than what we did. So I think building it up instead of subtracting what you don't want is easier in this case. More polar, if you can find a year with it, I can do it. Or more multiple choice. There's 16 people now. I am the GOAT. Thank you. Any other requests? The third free response in 2007 is good. Okay, let me download that. It might take a second to load. Well, that's loading. Anything else? Euler's method. Okay. Well, that's loading. I'll just make up an Euler's method problem. Say dy dx, whoa. dy dx is x plus 2y. And we're told y of 0 is 2. And I want y of 1 with 2 equal steps. I think, let's not call people idiots in the chat, please. Let's be respectful. I think Euler's method gets overly complicated. Some BC Calc teachers make this gigantic table, and I think you just need a few columns. Four columns is all you need for Euler's method. What is x? What is y? What's the slope? What's the tangent line? The x and y we're told. This will help us find the slope, which is 0 plus 2 times 2. Well, now that we have a point and a slope, we can write the tangent line. I like to not write it literally in point slope, but I like to add this over to get y on its own. So there's the equation of the tangent line. Okay, so now we want to get to 1, right? That's our destination, but with 2 equal steps. So 1/2 would be the next x. The tangent line always helps you find a y given that x. So our next y would be 4 times 1/2 minus 0. 4 times 1/2 is 2, plus 2 is 4. Plug that in and we'll get the next slope. 1/2 plus 2 times 4 is 8.5. That's 17/2. Yeah. We build the tangent line again. There's our slope. There's our x. There's our y scooted over. Now plug in 1. 1 minus 1/2 is 1/2. Times 17/2 is 17/4. It's 33/4 when you do the fraction arithmetic. So all Euler's method is just repeated tangent line approximation. The differential equation helps you find the slope. With a point and a slope, you can get the tangent line. Plug in that next x to get y. X and y get the slope, tangent line. Plug in that next x to get a y, on and on. So keep it simple. The table just needs to be these 4 measurements: x, y, slope, tangent line. Yeah, I know that many teachers have many other columns. It's like this is all you need. What else is going on in the chat? Someone is saying things. Could we do one of each of the most likely free response? No, you will not get points off if you set up Euler's method differently. There's so many variations. It's more of just the process and the answer. Predictions, I mean, for BC, I don't know. This is just my opinion. I think 1 is often an accumulation in rates problem. I think 2 on the BC will be 2D motion. 6 is guaranteed to be a series. 5 is often differential equations. 3 is pretty commonly graphical analysis. 4, there's some variation. It could be polar, maybe. It could be like an integral application problem, like areas, volumes. So this is the sort of uncertainty, but AB, I mean, remember BC and AB have 3 problems in common. Those would be these. Or maybe these. What else is in the chat? Riemann sums. Oh, these are your guesses. Yeah, 2D motion's what I mean by, you have an x of t and a y of t. Most likely they'll tell you x prime and y prime to see if you can integrate to get back to x and y. Yeah, I haven't seen logistic that much on differential equations, as much as just a common separation of variables problem. Which one of those? A differential equations problem? What do you want to see, Rigatoni? I don't know. I'm just guessing. Does 2018 have something promising? Not really. Let's look at 19. No. 2021. Here's a differential equation problem. 2021. Let y equals f of x be the particular solution with that initial condition, and they tell us f double prime of 1 equals 4 for some reason. Build a second degree Taylor polynomial about the center x equals 1. So get really comfortable either building a Taylor series from scratch, term by term, or manipulating a series you already know. You should know e to the x, sine x, cosine x, 1 over 1 minus x. So to build a second degree Taylor polynomial from scratch, we need to plug in the center, the derivative of our center, x minus 1, and 2 derivatives at our center, x minus 1 squared. Don't forget the factorial. Do we know f of 1? Yes. Do we know f prime of 1? No. So we need to fill that in. Do we know f double prime of 1? They told us that. It's 4. We're almost done. How are we going to figure out f prime of 1? Maybe that's where the differential equation can help. dy dx is f prime, right? So dy dx, when x equals 1, would be, well, what's the y coordinate when x equals 1? They told us that. It's 4. Times 1 times ln of 1, right? We're plugging in 1 for x. And with it, 4 for y. The natural log of 1 is 0. So f prime at our center is 0. Write the second degree polynomial about that center. We did it. Use Euler's method to approximate f of 2. So what I like to do again is just write these 4 things down. The xy they told us was 1, 4. We're trying to get to 2 with 2 equal steps. So we'll have to visit 3 halves along the way. What is the slope? Well, the slope's determined by this. So at 1, 4, well, we did that, right? The slope was 0. So this would just be y equals 4. So now we go to the next y, which is 4. And we plug in this point. That would be 4 times 3 halves ln of 3 halves. So what's the tangent line? It's that ugly looking slope, which I guess I could make 6 ln of 3 halves. X minus my x value plus the y value. I like to solve for y in point slope. Now plug in 2. It'd be 6 ln of 3 halves. 2 minus 3 halves is 1 half plus 4. Half of 6 is 3. So there's my approximation of y of 2, or f of 2. C says, actually solve it. This is common in a differential equation problem. The actually solve it is, do you know separation of variables? So I'll write this down here. Let's get all the y's together and all the x's together and integrate. This is easy. Technically absolute y. How are we going to integrate x ln of x? That's a bit weird. We need by parts. I told my class, Lipit is a way of determining what a good u choice is in by parts. If you have a log, make that u. If you have an inverse trig function, make that u. If you have a polynomial, make that u, and so on. E is exponential, t is trig. Well, we already have a log, so that's going to be u. dv is everything else. We derive here and anti-derive here. So x ln x would become uv minus the integral of v du. One of these x's cancels, and we can integrate x over 2 to x squared over 4. Don't forget a constant. We're told when you plug in 1 for x, you get out 4 for y. 1 for x here would make that go away. So C is 1/4 plus ln of 4. So to conserve space, I will write that here. Lastly, solve for y. Well, that's easy, just exponentiate. Might as well just leave it like that. Yeah, that is sort of weird. Is it right? Let's see. You know, you can search just the year and then scoring guide, right? And you can see the solutions. What was this problem, number 5? I'm on the wrong year. Let me try again. Number 5, Euler's method was, oh, I missed a problem. I forgot to do this part. Use it to approximate f of 2. I forgot to plug 2 in. So when we plug 2 in, we'd have 4 plus 2 times 2 minus 1 squared. That's 4 plus 2 or 6. So I would have missed a point for not plugging 2 in. B was this Euler's method thing, which they have 4 plus 3 ln of 1.5. Yep, that's what I got. And part C was, yeah, that convoluted answer. Literally this. Hopefully it's a bit cleaner for this year. Okay. Can we do analysis between f double prime? Sure. That's often problem 3 or 4. It sort of varies. So this would be a good one. They give us a graph of f, which is the thing we're integrating. So this is an integral defined function sort of problem. On what open intervals is g concave up? Well, if we take the derivative of g, we'll get f prime, right? If we take the derivative of g, we'll get f. But if we take 2 derivatives of g, we'll get f prime. That's testing your understanding of the fundamental theorem of calculus. Deriving an integral is essentially back to f. So to be concave up, we need g double prime to be 0. I'm losing steam. For g to be concave up, we need g double prime to be greater than 0, which means f prime must be greater than 0. F prime is positive when we have a positive slope, right? So that would be from -4 to -2, or from 2 to 6. Another way to say where f prime is positive is where f increases. Part B, let p be this function, derive it, that's this product rule. Plug in 3. What's happening with notability? There we go. Plug in 3. Okay, now we just need to figure out what all of these are. Well, g prime of 3 is f of 3. Right, we established that here. G prime is f. So g prime of 3 times f of 3 is just f of 3 times itself. And what is f of 3? It's -3. G of 3 is the area from 0 to 3 of f. The area from 0 to 3 of f is this area together with that area. The first area is a 4 by 1 right triangle. 1/2 base times height is 2. This part is a 4 by 1 right triangle just the other way, so those would offset. And from 2 to 3 is 1, 2, 3.5, but negative. So what's the total area accumulated from 0 to 3? 2 and -2 cancel, we get -3.5. So g of 3 is -3.5. And f prime of 3 means the slope at 3. Well, that's just up 1 over 1. So we get 9 minus 3.5, that's 5.5. C, find the limit. Please, on the AB or BC exam, do the limits separately. They will not give you a point of, say, the 3 points if you just write 0 over 0. You've got to show each separate limit. What happens to g as x approaches 2? Well, we'd be integrating from 0 to 2, right? If we integrate from 0 closer and closer to 2, that would be 0, right? Those integrals would offset. And as we approach 2 for x squared minus 2x, well, that's 4 minus 4, 0. So the AP expects you write these separately. Now that we have 0 over 0, we can use L'Hopital's rule, because we have an indeterminate form. If you just write 0 over 0, they will not give you that prep work point. How does L'Hopital's rule work? We take the derivative separately. No quotient rule here. Well, that would be g prime of 3 over 6 minus 2 is 4. G prime of 3, remember we established, is f. And f of 3 was negative 3. So there's part C. Show these separate limits before you use L'Hopital's rule. D, find the average rate of change of f on the interval blah. The average rate of change is just the secant slope. Well, what is g of 2? That is the area from 0 to 2, which we've said a few times is 0. What is g of negative 4? That would be the area from 0 to negative 4. Well, let's try to figure that out. This is a 2 by 6 rectangle, so area 6. This is a 2 by 2. I'm clearly crashing out. That's a 2 by 6 triangle whose area is 6. This is a 2 by 2 triangle whose area is 2. And this is a 2 by 4 rectangle whose area is 4, right? All that together is 12. But we integrated from 0 to negative 4. 0 to negative 4 would be negative 12. 2 plus 4 is 6. 12 over 6 is 2. So the average rate of change is 2. Does the mean value theorem guarantee a C for which g prime of C is equal to this average rate of change? Well, to be able to use the mean value theorem, our function g must be differentiable and continuous. Is g differentiable? Well, yeah, the derivative of g is f. And is g continuous? Well, g is just integrating what's under the curve. And since g is differentiable, it's also continuous. So we can use the mean value theorem. Always check the conditions. So does the mean value theorem guarantee a C for which g prime of C is equal to this average rate of change justify? Since g is differentiable and continuous, the mean value theorem applies, which would mean that this instantaneous rate of change should be the average. So I would say yes. Is that the right conclusion, I wonder? Someone asked about why did you not take the limit at 3? Why did you take the limit at 3 and not 2? Where are we talking about? Yeah, I don't know why I did 3, because I've been at this 4 hours, probably. Good catch. So C should have been this limit, right? Yeah, I did it fine with 2 here, and then 3 somehow magically happened. So yeah, back to this. We should have had, we should need to use L'Hopital's rule again, it looks like, right? So let's see. With 2, not 3, what's g prime approaching as x approaches 2? Well, g prime is f. What's f doing as we approach 2? F is approaching a value of negative 4. And 2 times 2 minus 2 is 2. This should have been negative 2. Thank you to Adam for catching that. Yeah, I've been at this since 4. Oh, I guess it's only 3.5 hours. I'm bound to make mistakes at some point. So I'm just checking, how did we do with this? This is 2021, number 4. Problem 4, you get a point for saying g prime equals f. The intervals should have been negative 4 to negative 2 and 2 to 6, so we got that one right. B should have been 5.5. We got that one right. Thanks to Adam C should have been -2. We got that one right. And D, the average rate of change should have been 8/3. So what did I do wrong? That should have, G of -4, I must have miscomputed. So let's do that again. So this is a 2 by 6. So that's 6, right? 1/2 base times height. This is 2 by 2. 2 times 2 is 4. Half that's 2. Yeah, 2 times 4 is 8. So the total area is 16. So this should have been 8/3. But yeah, the argument's sound. I just had the wrong number. Since G prime is F, we know G is differentiable. And since it's differentiable, it's continuous. Never say it on the AP. I'm just being loose in my language now. Since G is differentiable, G is continuous. So the mean value theorem applies. Sure, Adam. Okay, for those, who's been here the whole time? Has anyone been here since 3 or 4, whenever I started? Nobody. We could run through another multiple choice. Would that be fun? Can you explain when to do endpoints? Sure. So whenever you're asked, is there an absolute max or an absolute min on a closed interval, you have to consider both the endpoints and the critical values. What are the critical values? It's where the derivative is either 0 or undefined. So this is often asked in like part B or C of a free response. What is the absolute maximum or absolute minimum of this function on this closed interval? Make a simple table of x and f of x. Say the endpoints were 0 and 8. And there might be critical values along the way. Maybe those were at 1 and 4. I don't know. So these are critical values. These are endpoints. Only when they ask for an absolute max or min. Now just plug those into the function just to make things up. Say this was 3, 8, -1, and 10. And I said, what is the absolute minimum value of f? Well, the absolute minimum value would be at -1. If I said, what is the absolute maximum value, it would be 10. If I said, where does the absolute min occur, you'd say 4. Or where does the absolute maximum occur, you'd say 8. Because a function could do something like this, and where we end up could be higher than where a relative max is. That's why we're testing the endpoints. A 2D motion request, sure. That's often number 2 on the BC. If you're not taking BC, number 2 is often a 1D motion problem for the AB students. Okay, so we're given the velocity. That's often the case. So immediately this is x prime of t, and this is y prime of t. We're told x of 0 is -2, and y of 0 is 5, right? That's what this information means. So they told us the derivative of x in an initial condition. They've told us the derivative of y in an initial condition. Part A wants the speed. The speed is defined as the derivative of x at some time squared plus the derivative of y at some time squared. The time in this case is 1.2. So I prefer not busting out the calculator and wasting your time typing all this in. But what I told my students is define this as like f of x and define this as like g of x, typing x, not t. And since that is what x prime and y prime is, you could just write f of 1.2 squared and g of 1.2 squared. Give things names, and then you don't have to type it over and over. So whatever that is, find the acceleration vector. Well, if we have velocity, we just need one more derivative of what they gave us. So if I called that f and g, I need f prime at 1.2 and g prime at 1.2. So A is just, do you know the definition? Speed is this Pythagorean theorem work. Acceleration is one more derivative of velocity. Find the total distance traveled. Well, that's us integrating speed. From 0 to 1.2. And again, they've told us these two functions, right? That's the two functions above. If you gave those names like f and g, you don't have to type it over again. C, find the coordinates of the point at which the particle is furthest to the left. Okay, well, left and right is controlled by x. So to be furthest left, x of t must be the most negative. Do you buy that? Adam, on the BC, they will, they could ask for the displacement in one direction, like what is the displacement for x from 1 to 5, or for y from 1 to 5, but they will never ask about the general displacement of the particle. Though it wouldn't be that hard, right? You would just, maybe I should say never, because I'm not working for a College Board or whatever. If they asked it, what you'd have to do is figure out where you ended, the position of where you ended, figure out the position where you started, and just find the distance between those, which is like the Pythagorean theorem. But I have not seen that question. Okay, so back to this. To be the furthest left, x must be the most negative. What does that mean? If x prime was negative, more negative, more negative, more negative, and then started becoming positive, if x prime changes from negative to positive, that means we're stopping there and heading to the right now. So what we just need to do is graph x prime, which they told us, and see where it changes from negative to positive. So I'll leave that to you to graph t minus 1 e to the t squared. See where that graph is going from negative to positive. That's where we're heading to the left, but then start heading to the right. That's where we're furthest to the left. It says, explain why there is no point at which the particle is furthest to the right. We'd have to show that x prime never changes from positive to negative. Okay, now I'm curious what this graph looks like. Let's do it. I never graph things with t. I always type x in place of that t. If I graphed x minus 1 e to the x squared, yeah, we definitely change from negative to positive, but we never change from positive to negative. So we head to the left, stop, then start heading to the right, but we never head right, stop, and head to the left. We just keep heading to the right after that. So this one's pretty simple. It's calculation heavy, but you can do that part. Other things. I'm wanting to speed run through another multiple choice, but no one's clamoring for that apparently. Or of course, if AB students are here, let's do some AB stuff. Try some multiple choice. I don't know what this one is, but sure, here's a random one. Dumb question, but how do you know which function is upper and lower for a Calc AB problem? Because it would be f, right? Just look at the graph. To answer Claudia's question. Yeah, I'll wrap up soon. Say you have y equals 2x and y equals x squared. So this is to Claudia's question. Maybe I'll extend it a little. Okay, so y equals x squared is the parabola, y equals 2x is the line. How do I know which order to subtract? Well, in this region, isn't the line always above the parabola? So if I wanted that area, I'd subtract in this order. Now I just need the bounds. Well, if I set 2x and x squared equal, that would occur at 0 and 2. So my advice would be, Claudia, just look at a graph. Okay, I'm going to wrap up by 8. So I'm going to try to speed run through this multiple choice set, and then we'll call it a day. But this has been fun. So problem 1, integral. This would be fine for AB as well. Just divide by x squared. Integrating x gives us x squared over 2. Integrating x to the negative 2 gives us x to the negative 1. But you need to fix that by dividing by negative 1. So that would be C. 2, what's the slope of the tangent line? When you take the derivative, you get 1 over 2x, but times 2. And when y is 4, you get a fourth. 3, if I take the limit of the numerator and the limit of the denominator, both are 0. I would highly suggest get in the habit of writing those separately. The AP free response wants to see those separately. So now we can use L'Hopital's rule, right? Let's consider deriving both. But sadly, these two limits are 0. So I do L'Hopital's rule again. Now cosine approaches 1, I get a limit of 2. So far, these are definitely AB or BC overlapped. 4 is more of a BC topic. If the denominator factors, use partial fractions. Clear the denominators by multiplying by the LCD. I then like to plug in 2 and 5 just to make half of it disappear. When I plug in 2, this will go away. So 1 equals negative 3a. A is negative a third. Plugging in 5 makes this disappear. B would be a third. So the point now is I can integrate these separately. A has a negative 1/3 coefficient. B has a positive 1/3 coefficient. Be on the lookout for undoing the chain rule when you're at this step. Here, there's nothing to undo, but if there's like a 2x, you need a 1/2. Okay, let's look at the choices. A third has to be there, so this is nonsense. It doesn't look like any choice, but that's because they're trying to be clever and use a log property. When you subtract 2 logs, you can divide what's inside. Since we're subtracting this one, that ends up in the denominator. So that's E. 5 is definitely A, B, or B, C. Which statement is true? If we approach 2 from the left, that limit is -1. And f of 2 is also -1, right? That's where the solid dot is. So 1 is true. So it can't be these. It's not worth checking 2 because 2 works no matter what. So let's check 3. When we approach 6, we get a limit of -1, but that is not f of 6. So that one is false. It can only be 1 and 2. Okay, 6, we have a series, and the nth partial sum is that. All the nth partial sum means is what you get when you add the first n terms. What if we push n to infinity? Well, if we take the limit of our partial sum, this limit would not exist, right? Half the time we get 1, but the other half of the time we get -1. So the series would diverge. So the limit of your partial sums is the infinite series. That's a BC only topic as well. This is definitely AB. What is the value of K? The limit from the left and right of 3 should match. So 3 squared plus 2 should be 6 times 3 plus K. That's 11. That's 18. K is -7. This is an AB or BC problem as well. Just let U be what's trapped, whose derivative is 16x. If you rearrange, that x is going to cancel. Don't forget to change the bounds. If x is 0, 1 plus 8 times 0 squared is 1. And if x is 1, 1 plus 8 times 1 is 9. Those are our new bounds. Don't forget to change the bounds. We have x square root of u, and here's our du. Those x's cancel. We can take out a 1/16, and that's u to the 1/2. That's u to the 3/2 times 2/3 times a 16th. Just keep rolling with the new bounds. Never have to go back to x. That is 1/24, 9 to the 3/2, minus 1/24, 1 to the 3/2. The square root of 9 is 3, cubed is 27. So we get 26 24ths or 13 12ths. Is that a choice? Indeed. So u sub with bounds, change the bounds, you're good to go. They give us the derivative. Critical values would be 0, 3, and -1. This is A, B, or BC. And now let's see what happens around those critical values. At -2, we have negative, positive, negative. So F's increasing. Between -1 and 0, we get a negative value, I believe. Between 0 and 3, say 1. 1 is positive, 1 minus 3 squared is always positive, and 1 plus 1 is positive. And test 10, I don't know, 10 times a positive number times a positive number, positive again. So where do we have a relative max? We have to go up and then down. That's only at -1. That's definitely an AB question. What is the sum of the series? Write out some terms. When you plug in 1, then when you plug in 2, then when you plug in 3, you see it's geometric. This is a BC question. What are we multiplying by each time? -2 is what the numerator changed by, and E is how the denominator changed, and that repeats over and over. The absolute value of R is less than 1, so we will converge. That's nonsense. And remember, A over 1 minus R is what we converge to. A is the first term, and R is -2 over E. I'm going to multiply everywhere by E squared just to clean this up. So this becomes -2, so it can't be that one. E squared, so it can't be that one. And a negative is positive, and we get 2e. So this is just testing, do you know how to work with a geometric series? A over 1 minus r. 11 is definitely an AB sort of question. It says find f prime of -1. Don't fall for it. First, check if f is even continuous. If it's not continuous, it can't even be differentiable. Very close to -1 from the left would be 2 times -1 plus 5 is 3. -1 from the right would be -1 plus 6, which is 5. F's not even continuous, so it can't be differentiable. What many students would do is write 2x, -2x, and go from there. Don't even check that if f's not continuous. A right Riemann sum from 0 to 2 with 4 subintervals. So how about we make a chart? We need 0 to 2, but with 4 subintervals. So we need 0, a half, 1, 1.5, 2. So there's interval 1, 2, 3, 4. F of x is 9 to the x. 9 to the 0 is 1. 9 to the 1/2 is the square root of 9. 9, 27, 81. In a right Riemann sum, if this is a free response, you've got to show how to use the function. So let's look at the first interval. A half minus 0 is our width, and f of 1/2 would be our right value. Then we go 1 minus a half with f of 1. 3 halves minus 1 times f of 3 halves, and 2 minus 3 halves times f of 2. The free response expects this raw setup before you even plug in from the table. Now we can plug in. We've got 3 for that, 9 for that, 27 for that, and 81 for that. If we take out a half, 3 plus 9 plus 27 plus 81 is what? That's 90 plus another 30 is 120, 60. So build a table. 13 is an optimization problem. A rectangular area is to be enclosed by a wall on one side and a rectangle of fencing on the other 3. Maybe we call this x, x, and y. 18 meters of fencing is used. So that means y is 18 minus 2x. The area is x times y. So if I distribute, this is now my area function of x. If I take the derivative to maximize it, the critical value is at 9 halves. Here's where the second derivative test would be really nice. If I take another derivative, that's -4 all the time, right? You can either do a sign chart or the second derivative test. If a double prime is always negative, then at that critical value must be a max. So 9 halves the value I want to use, but they want to know the area. So just plug in 9 halves for x. I've got an easier way, actually. Check this out. If x is 9 halves, and we use 18 total, that has to be 9, right? So the area, the max area is 9 times 9 halves. That's 81 halves. That's totally AB. 14 is BC. What is the fourth derivative at 0? You've got to be comfortable building any term in a Taylor series. So we do the fourth derivative times x to the fourth over 4 factorial. But compare that to this term. The x to the fourths match. 4 factorial is 24. 24 times 6 is 144. So remember, any term, the nth term, looks like this. We cherry pick the x to the fourth term. This is totally A, B, or BC. Just carefully work through implicit differentiation. ln of x's derivative is 1 over x. This is 1 over y, but y prime. dy dx and -4's derivative is 0. I like to plug in my values immediately if I have them. X is 4. Y is 4. Might as well multiply everywhere through by 4. That's a 4, sorry. So 1 would be 5 dy dx, 1/5. Here's a region, a polar question. Okay, so this is BC only. Here's a region in the first quadrant bounded by r equals theta and theta equals k. Of course, r equals theta is this one, and theta equals k is that one. In my day, when I took the calc exam, it was all paper pencil. It was great. I could draw over the picture. Yours is digital, so any picture stuff you'd have to redraw on your scrap paper, which is fine. Just be sure you draw it appropriately. What is the area of r in terms of k? Well, a polar area is 1/2 integral of our radius squared. The radius that we're going out to is theta. And we're integrating from 0 up to an angle of k. So the antiderivative work is easy. Plug in k, we get k cubed over 6. 0 doesn't contribute anything. So remember the polar area for BC students is this. 17. What is the Maclaurin series for e to the 3x? You got to know e to the x's Maclaurin series for BC students. All we need to do is put 3x in place of x. 3 squared is 9, x squared. 3 cubed is 27. So I don't know. Can we pick out what it is? It's not that, it's not that, it's not that. We need a 9. It's that one. 18 is a BC problem because you have an infinite bound. Disguise it as a limit. Okay, I know I'm going to have to use u sub for this. And when I'm doing that, when I'm doing an improper integral, I forget the bounds for now. So ignore the bounds. Let's integrate as usual with u sub. The derivative is 3x squared to make the x squared cancel. So that would be 1/3 integral u to the -2. Bump up by 1. Fix the power. Now let's go back to the bounds. With u plugged back in, that's 1 over x cubed plus 2. With these bounds, let's plug in b. When you subtract, we're going to add. That's 1/3, 1 over 1 cubed plus 2. When b goes really big, this goes to 0. We get a 9th. So that's a BC only topic. Make it a limit. Do u sub, but don't worry about the bounds for now. Point of inflection. Okay, we need 2 derivatives. This is definitely an AB sort of thing. We need to see where the second derivative is 0 or undefined. Of course, the undefined part won't happen. Let's factor. So we have 2 special values. Don't go for 0 and -2 yet. This 8/3 stuff is annoying or not purposeful. But we need to show there's a sign change, right? It's not just where the derivative is 0. If we test -3, 60 times -3 squared would be positive. -3 plus 2 is negative, so we get a negative there. If we test -1, that would be a positive answer. And if we test 50, I don't know, that would be positive as well. Notice we only have a sign change at -2. So a point of inflection is not where the second derivative is 0 or undefined. It's that and where there's a sign change around that value. That's why we made that chart. 20, they give us the derivative and we want g prime. Well, by the chain rule, we derive f prime, but times the derivative of what's inside. Let's plug in 2. 2 squared minus 1 is 3, and 2 times 2 is 4. Now plug in 3 here. 3 minus 2 is 1. 3 squared minus 4 is 5. So that's 5/16. Times 4, that'd be 5/4. Definitely AB for that. 21, we have a table for a differentiable function. Use a left Riemann sum with 3 subintervals to approximate the length of the curve. Okay, BC students, how do we find the arc length? From 1 to 7, we need to integrate 1 plus the derivative squared dx. dx is the change in x, which is 2 all the time. If we're doing a left Riemann sum, we're going to grab these values for f prime. So let's do it. We're going to have a square root of 1 plus the first f prime value squared times a change in x of 2. I'll write it vertically maybe. Plus 1 plus the next f prime value squared times 2. Plus 1 plus the next left value, which is 0 squared times 2. That's 2 root 5, that's 2 root 2, and that's 2. 2 root 5 plus 2 root 2 plus 2 is d. (22) BC question, interval of convergence. Get really comfortable with the ratio test. We'll bump up each n by 1. Then multiply by the reciprocal. Simplify what you can. There's one more x minus 3 up top. There's one more 2 in the denominator. And this n stuff doesn't algebraically simplify, but its limit is 1, same degree. And that ratio needs to be less than 1 to converge. So we at least know the radius of convergence is 2, and we're centered at 3. I like to draw a picture. If I go 2 away on either side, I should be looking at an answer something to do with 1 to 5. So these are all out. But now we have to test the endpoints. If we plug in 1, you get negative 2 to the n. Negative 2 to the n, I'm going to write as negative 1 to the n and then 2 to the n broken up so that these can cancel. This series converges by AST. It alternates, the limit is 0, and it decreases. So 1 is good. Let's keep the ones that have 1 in them. So it's between B and C. If we plug in 5, we get 2 to the n. But that just leaves 1 over n, which is harmonic. That diverges. So 5 is bad. Avoid it. It's got to be B. So we're on a streak of BC sort of problems. 23 is totally an AB question. And you could either test the choices or you could just solve it outright. I'll do the long way. You can separate the variables, integrate. If you plug in 1 for y, you should get you should be able to plug 2 in for x. 2 squared times a half is 2, so c is negative 3. I'm going to multiply through by negative 1 first. I'm going to get a common denominator here. You'll see why in a second. So that when I flip around both sides, I can easily do that. So it should be this one. Shavin asks 2 times e to the 3x. Well, write down the series for e to the x. You want e to the 3x. So everywhere x is, we'll put a 3x. Now just multiply by 2. That's not related to this problem though, right? which converge. Well, if that's the general term, the limit of that is not 0. So by the nth term test, this would not converge. While the limit of this is 0, this sum is very much like 1 over n, which diverges. So this one can't converge. This one is geometric with r equals a third. And since that's less than 1 in absolute value, 3 is the only one that will converge. 25 is also a BC question. Remember, x is r cosine theta, which is cosine theta times itself. And y is r sine theta, which is cosine theta times sine theta. Take the derivative. That'd be negative sine theta cosine theta, and the same thing all over again. The derivative here by the product rule would be negative sine squared plus cosine squared. Plug in pi over 6. You get negative 2 times sine of pi over 6 is a half, cosine is root 3 over 2. So that's negative root 3 over 2. Here at pi over 6, sine squared would be negative root, I'm sorry, negative, it would be 1/2 squared, but negative. And root 3 over 2 squared would be 3/4. So we get 2/4 or a half. How do we put all this together? We divide dy d theta by dx d theta. That should be this one. So just write down what x and y are from pre-calc, r cosine theta, r sine theta, plug in cosine, derive, divide dy d theta by dx d theta. This is very much an AB question, testing your knowledge of the fundamental theorem. We're going to plug in our upper bound. But don't forget, we've now created an inner function, so we need to do the chain rule. The derivative of root x is 1 over 2 root x. So we get 1 over 2 root x times 1 plus x, right? When we square x, when we square the square root of x. So that's a. So don't forget the chain rule, which happened here. Another BC question, sine squared of x. Interesting. So sine of x, remember, it's the odd ones and it alternates. And we want to square that. So I'm just going to multiply that by itself. We want the x squared one, right? So if I multiply x by x, that's x squared, and there's no other ways to get x squared. So the coefficient is 1. That almost seems too easy. The x to the 4th coefficient would be a bit more interesting. You just find all the ways you could get x to the 4th. 28 is definitely an AB question. It's understanding that the derivative of the inverse is the reciprocal at the corresponding point. So this is really important. H of 1 equals 2. So that means 1, 2 on H corresponds to 2, 1 on H inverse. What is the derivative of H at 1? Well, 5 would come down. That's 5 plus 3 or 8. That tells me H prime, H inverse prime at 2 would be the reciprocal. So if I know H prime, I do 1 over its slope, just realizing 1 for H is the same as 2 for H inverse. Oh, well, whenever this test was given, there were only 28 non-calc. Okay, I think I'm going to call it a night. I need to take my dog a walk. So this was fun. I did 4 hours of AB and BC practice. I really appreciate your time. And good luck tomorrow. Hope to do this for other stuff too. So maybe I'll do this again for SAT prep or something. Yeah, give me a 5. All right, good luck. Bye, all.